Welcome everyone. My name's Lofi Mage, and you're watching Disney Channel. We are back with the Learning Unity Essentials stuff. This is day 2, and we're picking up from yesterday, where we had kind of worked on this room here. And basically this room was a lesson in like working with prefab, setting up physics and stuff. So this ball falls, it has gravity, hits the ramp and it rolls. And yeah, next step is to set up a tower of blocks for it to crash into and do more physics stuff. That's pretty much where we're at with this. We're about 30% of the way done through these, entry-level missions or whatever, however you want to word that. So yeah, that's kind of where we're at. If you are not familiar with what's going on, if this is confusing to you, please go view day 1, where there is like more of a setup to how we got here. And yeah, so that's kind of it. I guess I should have said at the beginning that what makes this special, I suppose, is that I'm an experienced developer. So you have that kind of a perspective in going into these things, this like tutorial stuff. So there may be some, something to gain from that if you're you, I don't know. But if anyone has any questions at any given time, please feel free to ask. Doesn't matter how silly or whimsical you may think they are. I suppose there is a limit. Please just like, don't sit there and fucking rage bait me maybe. But like, please feel free to, ask whatever questions that satiate your hunger for knowledge. So let's go ahead and just like get into it. My OBS keeps crashing. I think it's because the built-in Chromium browsers don't like other Chromium browsers all of a sudden. So I can't use Chromium as a spare browser. I can't have Discord up at the same time. Oof, that is an icky situation. I'm so sorry. I was hoping for the Disney Channel callback. Well, there you go. Congratulations, you got it. Okay, all right, so we are making a tower of prefab blocks. The summary for this one is use new primitive shapes to build the balanced structure, learning about colliders and prefabs. Very cool. So number 1, overview. In this tutorial, you'll create a few block towers that your bouncing ball will be able to knock over. When you're ready to get started, go to the next step. Let's go ahead and watch this video. I guess I should honestly like full screen it so y'all can see. So it hits the ramp and it just crashes into the blocks. That's what we're doing, gang. Let's mark that as complete. But what if I hunger for rage baiting? No. Just no. Number 2, add a block and reset its transform. You're about to begin the construction of your block tower. To make your first building block, you'll start by adding a primitive cube. Just like you did with the sphere, you'll add it to the scene, rename it, then reset its position to the origin as a starting point. However, this time you'll use a new technique for creating the new 3D object and a new technique for resetting the object's position. Transform? Woke ass tutorial. Instructions. Step 1. At the top of the hierarchy window, select the Add button to access the Create menu, then select 3D Cube. Okay. This technique gets you to the same menu as right-clicking an empty area in the hierarchy window. Rename the cube to block. In the inspector window, select the More menu in the upper right corner of the transform component and select Reset to reset the cube's transform properties, including resetting its position to the origin 0000. This should position the cube in the center of the room, halfway sunk into the floor. Oh, it's transform here. Cool. Yep, halfway sunk into the floor. Step 3, reposition and scale the block. In this step, you'll reposition the block so that it's in the path of the ball and edit its scale so that it looks more like a classic kid's building block. However, rather than editing the scale in the transform component directly like you did with the ball, you'll actually use the scale tool in the scene view. After you master the scale tool, you'll have mastered the 3 most important tools in the scene view: move, rotate, and scale. In the hierarchy window, select the block game object. Selected. 2. Use the move tool to reposition the cube above the floor where it will get hit by the ball. Okay. Select the scale tool and using the X, Y, and Z handles to scale it down so it's a tall, skinny block that the ball can knock over. You can confirm in the inspector window, but it should be about 0.1, 0.2, 0.1 on the X, Y, and Z scale values. For faster editing, flip between the move, rotate, and scale tools using the W, E, and R keyboard shortcuts in the scene view. Cool. Yeah, okay. We want to do a kids block. What is it? 1.25 and 1. Yeah, it's pretty close. Press F to frame it in the scene view for a clearer look and make sure that it's just sitting above the floor. We're going to want to switch back to the move tool. Yeah, I'd say that's pretty damn good. And then enter play mode to see the ball. Unable to knock over the block, which is something you'll fix in the next step. So does that mean it wants us to move it in front of the ball, or? Yeah, so it just hits the cube and then rolls the fuck away. Cool. I mean, hey, that's something. That's kind of neat, right? Or add the rigid body component. In this step, you'll add a rigid body component to the block game object. Initially, the block won't move when hit by the ball, acting like an immovable brick wall. This behavior is due to the lack of a rigid body component, which governs the physics properties of the game object. With a rigid body component, the block can react to a collision and fall over. Step 1. With the block game object selected, select Add Component at the bottom of the inspector window, then search for and add a rigid body component. Okay, we've got that. Oh yeah, because it comes with a box collider. That's why the ball just doesn't phase through it, by the way, like it did with the ramp. It's because the ramp did not come with the box collider. This cube that we generated does. We'll add a rigid body. And it just says to go into play mode. Yep, there we go. Knocks it the fuck over. It says, get down. Awesome. Now create a block prefab. In this step, you'll transform the block game object, which you've already enhanced with a rigid body component, into a usable prefab. Prefabs in Unity are game objects with all their components and properties already set up so that you can reuse them as a template. You can keep these custom prefabs in a folder in the project window for future use. Step 1, in the project window, navigate inside the prefabs folder, which we are already in. Step 2, select the Add button at the top of the project window, then select Folder and name the new folder My Prefabs. The top of the project window. My Prefabs. Just like you did. Oh yeah, we've already done that. Okay, click and drag your block game object from the hierarchy window into the folder. Cool. 3, click and drag your... No, I already did that. I'm sorry. Okay. Well, we did it. And then it says this has turned blue. Observe that the block in the hierarchy window, that's this one, turns blue, indicating it's a copy or an instance of a prefab. Number 6, create a tower from prefab blocks. Now you'll use the block prefab you created to build a small tower in your Unity scene. The process of constructing a tower not only attests your ability to use prefab sufficiently, but it also allows you to experiment with object positioning in Unity. The tower doesn't need to be perfect. As long as it stands up, it'll work well. In fact, it may even be more visually interesting if it's not perfectly aligned. Instructions from the scene view toolbars. Locate the center/pivot dropdown and make sure that center is selected. And what is that? From the what? Oh, this is back in the scene view. Okay. And it's center, right? Yeah, so center is selected already. If pivot is active, your blocks will end up halfway through the floor at their pivot point. Okay. Drag multiple instances of the block prefab from the project window into your scene, positioning them to form a tower. In order to make sure your blocks are aligned, you should examine the tower from all angles. Sometimes it might look aligned from one angle, but not from another. Try framing the block you're working with and orbiting it, or using the scene view gizmo to examine it from different angles. Can do. So basically we're just gonna kinda, oops. And from the prefab folder, yeah? Yeah, from the project window, okay. Need ABC blocks that spell Pocky maybe, or I think that's too advanced. For the moment, probably too advanced. Okay. I don't know why it wanted to scale at 90 degrees, but that's fine. Okay. I think that's close enough to be interesting. We will turn off the rotation. I don't know. Again, that's so weird that that shit's rotated, but... Yeah, that should be good. Hell, maybe we'll even do one more. Let's go ahead and clear the rotation on this. So basically what I just did is I went into the prefab itself. I zeroed out the rotation. That fixes it for all future times that we click it and drag it in here. Okay, let's go ahead and see how the tower behaves, I guess. That's so cool. I like that. I like that a lot. Awesome. Mark step is complete then. Okay, 7. Reduce the weight in prefab editing mode. Goal for real. You may have noticed that the ball had a hard time knocking over all those blocks. Did it? Maybe if we place him back a little bit. Yeah. Okay. By default, the rigid body sets a component's mass to 1 kilogram. Your 1 kilogram ball is trying to knock over a tower made of 3 kilogram blocks. In this step, you'll reduce the weight of your block prefab, and in doing so, reduce the weight of every block in the scene. That's the beauty of prefabs. To do this, you'll enter prefab editing mode, a powerful feature in Unity that allows you to edit a prefab asset directly. Prefab editing mode isolates the prefab, enabling you to make changes without affecting the rest of your scene. So in the Unity editor, locate your block prefab and then double click it. With the block prefab in prefab editing mode, navigate to the rigid body component in the inspector window and reduce the mass property to just 1/10 of a kilogram. To exit prefab mode, select the small back arrow at the top of the hierarchy window. Yeah, there is a problem though, because this block is not using the prefab. But this should fix it, maybe? Cool. That's not what I wanted to frame around. All right, so now it has that mass. After exiting the prefab editing mode, test the changes by entering play mode. Observe how the ball can now much more easily knock over the tower. Okay, let's do that. Oh yeah, the blocks just go fucking flying. Very cool. So next step 8, add a material to the prefab. In this step, you'll change the block's material using prefab editing mode, so it's not that boring gray anymore. You'll see the power of prefabs once again as you modify a single asset and see the change instantly reflected across all instances of that prefab. Instructions: 1, open the block prefab in editing mode. Yep. In the inspector window, in the mesh renderer component, locate the material property of the block prefab. In the mesh renderer, here's this lit material. This action, select the object picker next to the material property. So that's this right here. So now it says browse through the list of materials. You'll see various options, including some designed for furniture, floors, and so on. Some of them might have unintuitive names. Select a material that applies to you and apply it to the block prefab. You can also create your own material like you did for the ball if you don't see one you like. Okay. Oh, that's interesting. Apple. We can't use the apple. Bar stool. Cheese. Can't use cheese. Expand it a little bit. But what is wanted cheese? What if wanted cheese blocks? We have to make our own, I guess. Knob, a bloody knob. Yeah, I really don't see one I like. Oh, that's because whatever we clicked on was the mesh and not the material. That makes a lot of sense. Okay. So now they can start looking a lot different. Well, let's try to see if we can find an actual like wood one. Yeah, there we go. Wood planks. Do this one. And now we exit the prefab editing mode. Yeah, now they look like very cool. So that's how we change the material. Organize blocks with a parent game object. In this step, you'll address the clutter in your Unity project's hierarchy window, caused by numerous block prefabs. You'll learn to organize these blocks under a single parent game object, simplifying your scene and making it more manageable. Sorry, let me sippy. Also, thank you for the good job. As a reminder, a parent game object is a game object that serves as a container for other game objects, known as child game objects. These terms describe a hierarchical relationship, much like a family tree. So step 1, in the hierarchy window, select the first block game object, then hold down the shift key and select the last block prefab in your list to select all the blocks in between. I'm guessing it means last block game object. You can hold control to select individual additional game objects or command if you're on Mac. So let's go ahead and do that. We click block, we go down to block 3, we click them all, and now they're all highlighted. Right click the selected blocks and choose create empty parent. Create empty parent, yep, there we go. And now we can rename it to block tower. So now that we have our, our block tower, when we frame it, it frames the whole thing. We can move around the tower as like one, which is pretty cool. Go ahead and mark it as complete. 10, turn the block tower into a prefab. The block tower you've created consists of multiple individual blocks arranged in a specific structure. If you convert this entire structure into a prefab, you enable the possibility of reusing this complex object multiple times within your project. You'll see that prefabs are particularly beneficial when creating repeated structures or patterns in your game environment. Instructions, step 1, in the hierarchy window, select the game tower, the block tower game object, which we do have right here. I guess we can underscore it. Click and drag it into the My Prefabs thing. So we just got to find that folder, which was in Prefabs, My Prefabs. And we got the block tower, and here's our little tower. Hey, I'm back. Do you know Unity yet? God, I wish. I wish it worked like that. Now you can easily create multiple instances of your block tower throughout your scene. Add a few more of these towers to your scene to make for an interesting collision. Okay, I'll check back in 30. Jesus. It's funny. Got another, like, there. And we'll kind of, we got 3 here. Let's see how that goes. So 2 of them get hit, and then this one just kind of like squiggles around. Bring them a little closer together. Yeah, there we go. Now they all get hit. Cool. If you want, edit the block in the prefab editing mode to make it a more interesting structure. The only thing that I will do, I think I want to rotate it a little bit like that, just to kind of get it, set up a little bit. That way it doesn't all look like it, it kind of, like, it looks different, you know what I'm saying? Like, we got some some block tower action going on here. Stares at camera intensely. Yeah, very cool. The throwable blacks, right? Adjust the ball's mass. With so many towers in your scene, the ball may once again have a hard time knocking all of the blocks over. But what would happen if the ball was 10 times heavier? Or 100 times heavier? Instructions, select the ball game object. In the inspector window in the rigid body component, increase the mass. Make it thiac to ensure it topples the block structure when it collides. Let's do it. So we'll go to the ball object right here. Me when I open the inspector window on my ball, right? She inspects my window until I ball. So we want to adjust the mass. That's 10 times heavier, okay. Yeah, now that shit got some roll to it. We ballin' for real, for real. Cool, now let's go ahead and do 100 times, as it said. This makes it 100 kilograms. Oh yeah, the blocks kind of go flying a little bit more, and the ball just pushes them effortlessly out of the way. Yeah, now what if we did a little bit more? What if we made that 100 times? Now it's 10,000 kilograms. Yeah, I don't really see much of a difference. That's fine. Okay. Review and proceed to next tutorial. Congratulations on creating a block tower experiment for the kid's bedroom. Here are some of the things you learned how to do along the way. Reset the transform component to reposition an object at the origin. Scale objects with the scale tool. Explain how to use prefabs in a scene. Make a new prefab from an existing game object in a scene. Identify a prefab instance in the hierarchy window. Switch the tool handle position of a game object between center and pivot. Edit a prefab in the prefab mode. Assign a material to a game object by changing the mesh renderer component. Make an empty game object as a parent for other game objects, and then arrange game objects in parent-child relationships using the hierarchy window. Sorry, chat, give me just 1 second. I got some, my glasses are hella dirty, so I'm just kind of trying to wipe them off a little bit. We ballin'. Kylo Ren, more. Can I say something that will have to make you cut this from your final edit? My social security number is 42069. Boob. I like that. I like that a lot. Awesome. Way to go. Okay, so we have completed this tutorial. Next, we're going to adjust the lights, background, and camera angle. Exciting stuff. So summary of this is edit the lighting, change the background, and position your camera for a perfect shot of your scene. In this tutorial, you will edit the sun, sky, and camera angle to get the perfect shot of the scene. When you're ready to get started, go on to the next step. Okay, step 2. Wait, why is that finance for my real social security number? Yeah. Adjust your camera. In Unity, the camera object is similar to a physical camera on a movie set, playing a critical role in how your scene is viewed. When you move the camera, you'll end up with a different view of your scene in play mode. Adjusting the camera's position, rotation, and field of view allows you to frame your scene just as a cinematographer would in filming. Let's try adjusting the camera angle and field of view. In the hierarchy window, select the camera game object. Okay, frame it. Whoa. And the toolbar overlay at the bottom of scene view. Toolbar overlay at the bottom of scene view. Right here. Enable the camera's option to get a preview of what the camera can see. Oh, that's fucking cool. Move and rotate the camera and notice how the camera preview changes. And now what? Very cool. Notice it. Are you noticing? Art thou noticing it now, Mr. Krabs? I am indeed. Now we use the field of view slider to change how zoomed in the camera is. Try and get a good view of the ball bouncing action, but don't worry about getting the perfect angle yet. We'll do that in the next step. So where the fuck is the field of view? In the inspector window. Okay. Yeah, that's cool as hell. Bowie JP, hi. Thank you so much for dropping on by. How you doing? All right, cool. On to the next step. 3, align the camera with the perfect view. It can be tricky to get the camera perfectly aligned using the move and rotate tools. There is a shortcut to get the camera angle you want by aligning the camera with your position and orientation in the scene view. Instructions. Step 1. In the scene view, use fly-through mode to get the perfect view of your bouncing ball and your block towers. Okay. Let me get this size down a little bit. Okay. Yeah, I would say that's probably about the best angle we can get. Maybe like a little bit lower. Select the game camera, or the camera game object in the hierarchy window, okay. Press Ctrl-Shift-F to align the camera game object with your current view. With the camera still selected, you should go to the main menu and select Game Object Align with View. Okay. Wait. Okay, main menu, Align with View. Cool. And now we can just, we can press play. Yeah, much better. Very cool. If necessary, tweak the position, rotation, or field of view property in the camera component to get the perfect angle. When you're happy with your camera angle, disable the camera's window overlay. Tip: trying to do these minor movements in the scene view with fly-through mode can be frustrating. Try lightly tapping on the WASD keys while holding the right mouse button to do small movements. You can also use the Q and E keys in fly-through mode to go up and down. Very cool. Step 4, adjust your lighting, or number 4. Lighting sets the mood and atmosphere of your scene. Unity's directional light, which acts like the sun in the real world, simulates bright midday sunlight. Give it bisexual lighting! If I can, we will. By rotating this light, you can simulate different times of day or specific lighting conditions. In the hierarchy window, select the directional light game object, then frame it in the scene view. Okay. Rotate the light to adjust the shadows and overall lighting. Note, changes in position won't affect the lighting due to its sunlight nature. It represents a light that's located infinitely far away and emits light in only one direction. So we just kind of wanna rotate for the sake of the shadows. Ooh, I kind of like the darker vibe of like nighttime. In the inspector window in the emission section, experiment with color and intensity to find the desired lighting for your scene. If you want more of a nighttime light, make the light more blue and decrease intensity. Yeah, well, first let's go ahead and do that. We will absolutely make the light more blue. Cool. Now let's see how that looks. Yeah, okay. I mean, it looks a little green, but like, yeah, sure, why not? Yeah, that's fine with me, I think. What is this? What does that do? None of our business is what that does. none of our goddamn business. Okay, 5. Edit the skybox. A skybox in Unity is a type of virtual backdrop that surrounds the entire scene, giving the illusion of a distant environment or sky around the environment you create. The skybox contributes a lot to the overall feel of your scene. In the project window, navigate to Unity Essentials, Materials, Skyboxes. The skybox currently in your scene is Skybright Cloudy. Okay, Unity Essentials, Material, Skyboxes. Browse the other skybox materials and preview them in the preview panel at the bottom of the inspector window. This is what we have. Ooh. We're gonna go with Sky Gray Night. Click and drag any skybox that interests you directly onto the sky in the scene view. To see how it looks behind the room until you find the one that you like. Okay, and then edit play mode tint. 6, edit play mode tint. Skybright Cloudy is my favorite character in MLP. Kinda does sound like it could be, right? As you've heard a few times up to this point, when you're in play mode, none of the changes you make are saved. Make sure to pay attention when entering and exiting play mode so that you don't lose your changes. By default, the editor windows around the game view become a tiny bit darker when you enter play mode to help visually distinguish between play mode and edit mode. This is known as the play mode tint. In this step, you'll edit the play mode tint to make it more noticeable so that you'll always realize when you're in play mode and avoid losing unsaved changes. Skybright, like the kids game with the light up pegboard. Yeah, that is over my head. I have no idea what that is. So we need to go to edit, preferences. Always save all the time, for real. It's really obscure, oof. In the left menu, select colors, then change the play mode tint color to have a subtle, color instead of gray. So we need to go for play mode tint. Let's do like orange. And then enter play mode to test it out. Yeah, that makes sense. Though that might be a little too dark. Do like a happy color. Yeah, that's noticeable. Play mode green, yeah. Yeah, perfect, cool. You'll look at it and say, that's a game, right? Okay, 7, review and proceed to the next tutorial. Congratulations on setting up the lighting, skybox, and camera so that you could get a perfect view of the block tower action. Here are some of the things you learned how to do along the way. Position the main camera in order to achieve the desired framing of the scene. Adjust the camera's field of view. Align a camera's view to the scene view with a keyboard shortcut. That's Control-Shift-F. Adjust the directional light to convey the time of day. Edit the skybox to change the setting of the scene. Adjust the play mode tint to make it obvious when play mode is running. Instructions. Proceed to the next tutorial, which includes optional challenge to further develop your skills, explore new concepts, and improve your project. I had a few when I was a little kid. Oh, light bright. Gotcha. Had a few when I was a little kid. Oh, that's so cool. Okay, 3D Essentials. More things to try. 1 overview. Try these optional activities to challenge yourself, build your skills, and improve your project. Sorry, let me sippy. That's a lot of pegging involved. Each challenge is tagged as easy, medium, or expert difficulty so that you know what to expect. You can do one of them, all of them, or none of them. It's totally up to you. Easy. Make a perfect block tower with vertex snapping. Medium. Add different shaped prefab blocks. And expert. Add and frame custom artwork. Yeah, let's do them all. We're in it to win it. So easy is number 2, easy. Make a perfect block tower with vertex snapping. This optional challenge is classified as easy difficulty. If you're interested in completing it, read on. Vertex, plural, vertices, is a point in which where the edges of shapes meet, like a corner. In Unity, vertex snapping is a feature that allows you to perfectly align the vertices of different game objects to one another by snapping them together. Vertex snapping is a little tricky at first, which is why this is an optional challenge. However, if you master the skill, it can be very useful. 1. Add a new block prefab to a spot on the floor, then drag another 2 blocks in the floor next to it. Okay. Let's just go down here and prefabs, my prefabs. Kinda add them here. Hold down the V key on your keyboard while you left click one of the bottom vertices of a block you want to put on top of another. Hold on a minute. Hold down the V key on your keyboard while you left click one of the bottom vertices of a block you want to put on top of another. I don't think I understand, but that's fine. Drag your cursor towards the target vertex of another block and the vertices will snap together. Oh. That is fucking useful. Wow. Medium, add different shaped prefab blocks. This optional challenge is classified as medium difficulty. If you're interested in completing it, read on. Okay. In the project window, go to Unity Essentials, Prefabs, and then Shapes. Click and drag one of the shapes onto the scene. Let's do a cone. Like a gnome hat. To make the shape detect collisions, add a mesh collider, then enable the convex property. To make it respond to forces, add a rigid body component. To give the new block some color, either create a new material for it and apply it, or select an existing material using the object picker and the mesh renderer component. We'll go ahead and create a new one just because it's been a while and we should stay sharp on our skills. We're gonna do cone mat. I think I want to do like a red plasticky kind of vibe. Plastic is very fucking smooth. Yeah. Okay, position the shape in an interesting position in your block configuration. You might want to scale these shapes proportionately. Yeah, we can do that by making sure that happens. And then yeah, it seems proportionate to me. Okay. Repeat this step for other blocks to try and make the collision more interesting. So I think what we can do... put one like right behind this. Kind of have it like blast off a little bit maybe. And then we can do another shape. Let's do an arch and let's have the ball go through it. How about that? So we can do the same thing. Let's go ahead and make a new material. And actually make it metal. And we can rotate it a little bit like so. And let's see what happens. We'll do the same thing. Mesh collider, convex. And just to make sure that it's not actually... Actually, it doesn't need any physics. It doesn't need any physics. Yeah, so there is a little bit of a problem here. Because basically once it doesn't want to let us go through this hole, which is a bit of a problem. And I don't really know how to fix that, if I'm honest. that's not really Jesus Christ, Fidget. Yes, I do. I'm a wizard at it now. I'm gonna try to like look it up and see if maybe there's a answer, like arch, like Unity arch mesh collider underneath. So I'm just gonna kind of go off script for this. Hooray! I'm gonna go to sleep. Okie dokie, artichoke. I hope you have a good night and sweet dreams, and thank you for dropping by. So yeah, let's go ahead and take off this mesh collider, because we can add other colliders. So let's go ahead and do a capsule collider. If we can. Hold Alt after clicking Control handle to pin center in place. Hold Shift. Scale it. Fuck, come on. Yeah, I'm not really sure, yeah, not really sure how the fuck to... Hmm. Yeah. I don't really know. I don't really know what I'm doing, if I'm honest. Oh my god, you know you got a banger when a kitty is jamming out to lo-fi. Yo, what do you mean? Yes, moving it up was what I was thinking. Yeah. We kind of do like that. And then can we... We can add another capsule collider. Can we change the name of that, maybe? No? I was thinking about this one. We can kind of like... Fuck. Yeah. So like this. Yeah. Look at this. So we're getting it. And we just need one more capsule collider. If we can just maybe copy. And then paste somehow. Yeah, and let's see if this works. What happened with our cone? It actually stopped the towers from knocking over the other one. So if we just kind of... Will it block or will it phase through? Oh shit, chat, it fucking works! Let's go. That is so fucking sick. Now let's put the cone in a more interesting spot. What happens if we just like put it there? Oh yeah, that just makes everything kind of blast. Yeah, that's so fucking cool. Oh my god. I made a beef veggie soup for dinner and ate it like 6 hours ago. Still burping it a little. It was very beef fat heavy. Damn, I feel like that. I feel beef fat sometimes. But that sounds good though. Very cool. Very awesome. Okay, so I'm pretty sure that, yeah, I killed this challenge actually. Expert, add and frame custom artwork. This optional challenge is classified as expert difficulty. This room is still sort of bland. It would benefit from some custom artwork. Adding some artwork also allows you to personalize this room a bit more and make it your own. To accomplish this, you'll need to create a blank art canvas using a quad primitive, then import and apply an image of your choosing as the quad's material. Finally, you'll make it look a little nicer with a frame. So right click in the hierarchy window and then we create a 3D quad. Like, what the fuck you call me? Ba, ba, ba. Actually, we can create an empty parent for this and call it perfect block tower. And now we can create a new 3D quad. In the transform component of the quad, set its Y rotation to 90 so that it will lay flat against the wall. And position it against the wall using the move tool. Change the Y rotation to 90. Very cool. This wall's pretty busy. You do this one though. There we go, because this side's invisible, but this side's not. I just noticed that. Okay, I'm trying to figure out if I can do like this vertical snapping shit. But I don't think I can. Yeah, I would say that's pretty perfect. Go ahead and place it up here or something, and you don't place art over the bed. That's bad feng shui. Okay, so find or create an image you want to use for your artwork. If you don't have one in mind, use one from the links below by opening the link, right-clicking on the image, and selecting Save Image As. Jesus Christ, I hope this doesn't end in fucking pornography. I'm gonna try my fucking best. Ah, Caddy, my beloved. This is the image we're gonna use. And what is this? Oh, but why? Okay. I'm glad that it tasted amazing, by the way. I'm sorry that I missed that. And what is your Y to? Create a new material in the My Materials folder. The feng shui bit, because the art potentially falling on your head at night subconsciously makes you anxious while you sleep, or at least that's, you know, where that comes from. Okay, so we want to go to models, no, materials, My Materials. Drag the image file into there. I didn't think there was anything, you know, odd, but I just wanted to make sure, you know. Oh, just never think about that because I make sure it's not gonna fall. Subconsciously though, that's the thing. You don't get to control what your subconscious mind does. And it could not, you know, you very well may be, you know, like, you know, the uncommon folk who aren't affected by it. It's totally possible. Caddy. And she looks extra thick, extra wide. Anyway. Okay, and the surface inputs of your... Oh, I forgot to do art mat. Create art mat. Nah, we know what types of secret things you keep in your folders. You know what? True. Too true. In the surface inputs section of your art mats inspector window for the base mat property, use the object picker. So this is the art mat. Base map, use the object picker. And then basically we want to go find Caddy. Right? And adjust the scale to avoid image distortion. Okay. Yes. We can just do the art mat, drag it onto there. Oh my goodness fucking gracious. Oh my goodness gracious. I'm done. This is my masterpiece. Wow. Wow. It's come to life. I can't believe it. It's like a poster. Wow. You know what? Actually, it is fitting. Caddy can fall and crush me while I sleep. That's fine. Amazing. Wow. I want to take a screenshot of this. Hold on. Let me just move this on over here. Let me fucking project this onto this screen. Open up Threads right quick. And my Threads post is going to be somehow still managed. A low figato masterpiece, even in a tutorial. Ah, Caddy, my beloved. Happy cry. Just gotta find the right emoji. Perfect. Fucking perfection. All right, now let me catch up on fucking chat. I'm sorry. I'm sorry for goofing off too much. Okay. Excuse you, I spend way too much influencing my subconscious. Just don't ask how. 1010W, hell yeah. Thank you, Auntie, for loving it as well. Thank you, thank you. Okay, all right, anyway, fuck it. Let's continue with the rest of the tutorial, yeah? Adjust the frame. Oh, we duplicate the quad. Rename the duplicate frame. So yeah, let's actually rename this artwork. We duplicate that. We rename it frame. We stretch it to like 0.1. And then create a new material. I'm sorry, I just realized that I am just jumping around here. So basically what we did is we created the art. This was step 4. We created the art material. We applied it to the quad or the artwork game object. We imported the image by dragging it into the My Materials folder. Then we went into the art mats inspector and properties through the inspector window. We looked for the base map property and used the object picker, as denoted by this circular with a dot in the middle icon, to select the image for the material. We then adjusted the quad game object's scale to avoid distorting the image. What that looked like is it was just changing the height, the Y scale property by a little bit. We eyeballed it. So at that point, it's time to make a frame for it. We duplicated the quad. We can do that by, so what I did was I clicked on artwork, right-clicked it, and then went duplicate. However, we can do Control D, which duplicates it as well. And then I renamed it to frame. That's where we're at right now. I then went and I decided to scale it so that it's slightly larger than the artwork that it's framing. I did this by linking the proportions of the scale. So that way when I increase the X by 0.1, everything else also increases by the same ratio, which helps us with that Y value since it's, you don't want to do the math. You don't want to do the math yourself for that. So at this point, we have added a frame material. Let's go ahead and add it to the frame. So now the frame is white, as you can see. What we can do instead is I want to change that to black, actually. Like not black, but like a dark black. Or close black, near black. We're going to turn up the smoothness a little bit. It kind of looks like plastic rather than wood. And then what we're going to do is, in my opinion, the frame is sitting pretty damn well on the wall. So we're actually going to bring the artwork forward ever so slightly. And the way we're going to do this is we're going to see which position here changes. So it's the X that needs to change. So I'm just going to change it ever so slightly forward. This way it sits on the frame. Like perfectly sits on the frame. And there it is. The only thing I will say is Actually, we don't need to scale the Z. And I think the Y might be scaling a little bit too much. There we go. There's our fucking artwork. Hell yeah. Hell yeah. That's what I like to see. And so then I want to take both of these since they're part of one artwork, and I want to create an empty parent, and I'm just gonna call it like what? Poster. Cool. Hell yeah. Wow. I can't believe it. I can't believe it. This is a room. This is a room I'd want to be in. This is my room. I don't give a fuck about no little kid. This is my room. Floating ball included. We'll address that in therapy later. But yeah, anyway. We did it. Review and proceed to the next tutorial. Now we're on the mission 2 quiz. If it'll load. And of course, because why wouldn't it do that? So apparently this is just a fucking problem for people. Jesus Christ. Sucks that we're kind of beholden to this. Come on, motherfucker. You motherfucker. Come on. Are we just not going to be able to progress? Is this really what's going to stop us? That'd be kind of crazy. And I'm pretty hard pressed to believe that it's a server issue, considering there's like never any like question and answers happening on the Learn platform. It seems like it's pretty dead to me, so like Jesus Christ. Well, you know what? We'll have to come back to the quiz later. That's unfortunate, but kinda is what it is. So, well, this one's significantly shorter, so I won't do a break yet. Fuck. Come on, go back. Go back, bruv. Come on, come on. Uh-huh, come on. Bro. Okay, new mission, Audio Essentials. Add immersive sound to a kitchen scene with a variety of different types of audio. What you will learn in this audio mission, you will learn the fundamentals of implementing different types of audio into Unity scenes. You'll learn how to set the tone with background music, how to add realism with sound effects, and even how to implement spatial audio in a 3D scene. And the skills we will learn is developing 3D audio for a scene. Very cool. So the summary for this is to bring a kitchen to life with audio, including some background music, a boiling pot of water, and even some birds chirping outside. And guess what? Maybe we can even use our lo-fi. How sick would that be? I'm gonna go ahead and I'm gonna let the video play. In this audio mission, you will learn the fundamentals of implementing different types of audio into Unity scenes. You'll learn how to set the tone with background music, how to add realism with sound effects, and even how to learn implement spatial audio in a 3D scene. When you watch the video demos throughout this tutorial, make sure to turn on your computer sound. Okay, go ahead and watch.
In this shorter audio section, you'll learn the fundamentals of implementing audio within your scenes. Well-designed audio can completely transform a user experience. It can set the mood.
Was that the up music?
And even allow someone to fully immerse themselves in a scene. In these tutorials, your goal is to bring a kitchen scene to life with sound. First, you'll add a boiling pot to the stove. Then you'll give it realistic spatial audio, making it seem like the sound is really coming from that point in 3D space.
That's cool.
You'll set the mood with some background music, learning how to work with 2D audio. Finally, you'll add an extra layer of immersion with the sounds of birds chirping outside. Soon, you'll have a solid grasp of adding and mixing different types of audio to create rich, immersive soundscapes in Unity. So, let's dive in and make some noise.
Yeah, no, to keep it was the first 3 seconds of up to keep the copyright happy. Yeah, I thought that was up. What the fuck is up, my dude? Warg Walker, thank you so much for dropping on by. Sorry you came in at that time, but thank you so much. Welcome, you and all the raiders. Soul, hello. Thank you so much for dropping by. Warg, how are you doing? And to the rest of you, lovely folk, how are you doing? I hope that you're all having a fantastic night. You were doing streaming Vanquish. What is Vanquish about? So yeah, so I guess this one looks like it's going to be pretty easy. It looks like it's just implementing a little bit of audio into this kitchen scene that they've designed for us. Hopefully that won't be too much of an issue. So number 2 is to open the kitchen scene and enter play mode. In this step, you'll just explore the silent kitchen scene. The scene is already set up with a script attached to the main camera that will work in play mode. This script allows the user, you for now, to easily explore the environment with the WASD keys and listen to the sounds in the scene from a first-person perspective. By default, the main camera will have an audio listener component on it, which acts like the player's ears. When the audio listener component is far away from a sound, it should be quieter. When the audio listener component is closer to a sound, it should be louder. With this component, the camera acts both as the player's eyes and ears in the scene. In fact, Unity does not even allow you to have more than one active audio listener component in a scene. With multiple sets of ears in different locations, at what volume would you play a sound? Which, honestly, is a pretty fair question. Soul, thank you so much for bringing friends. How are you doing? So happy to see you here. Warg says, doing great. Monday's over. Rest of the week should be easy. Yes, absolutely. And I'm so glad to hear that you're doing great. Vanquish is like Metal Gear. Revengeance with rocket pants to slide around with. Very cool. Unfortunately, I don't think I've ever played a Metal Gear game. I know that's kind of wild, but like, yeah. But hey, rocket pants are cool. Sliding around is cool. So it sounds pretty neat. So heck yeah, heck yeah. And then Dr. Mech, hello. Thank you so much as well for coming in with the Raiders. Sorry that I missed you. How are you doing tonight? And better day today. Good. I am so happy to hear that. That makes me very happy. Good. I'm glad. Now that the what you were doing is over, what are y'all plans for the rest of the night? Anything exciting going on this week? So let's see. Back to this. The first step is in the project window in the Unity Essentials Scenes folder. Locate and open the third scene. Oh, Soul. Check this out. So, working on like game development stuff, and so this project was to set up this room. So I placed these objects. These objects are all things that I placed by hand. Just the walls and the windows were kind of built in. And these objects were also pre-made, but I placed them. But then, and one of the bonus objectives was to put art on the wall. You already know I had a blast. So there's Caddy. Caddy, my beloved. Okay, and now we're going and we are loading the next scene. I got some super cool plans. I'm going to watch a super cool streamer that makes fire music. Wow, they are honestly incredibly lucky to have you there. That is really neat. Sounds like a nice vibe. Okay, so a cute little kitchen. Okay, it's you, silly. I don't know who Yusili is. I've never heard of a Yusili. In the scene, use the fly-through mode or the frame orbit zoom technique to give yourself a good view of the kitchen. I think we did that. So now we use play mode to preview this. They mean you love? I don't know who you love is. Sorry, it's gonna be a mystery to me. Oh, that's interesting. Whoa. Ooh. Babs you. You know what? Fair. So we're gonna end up putting a pot of water on the stove to boil, I guess. That's neat. That is very neat. If you are using your to look up and down, use your mouse. Gotcha. Once you feel comfortable navigating and have explored the silent kitchen scene, exit play mode. Cool. In the hierarchy window, select the main camera game object and locate its audio listener component. So this is the main camera, and here is the audio listener. We've done that. Great. Beats with Pool Noodle. Take a compliment. Huh? Who are you? Where am I? What am I doing? What is this? Why are you people watching me? You perverts. Number 3, add a pot to the stove. Now you'll add a pot to the stove in the kitchen. The pot comes equipped with a particle system for the steam and for the boiling water. Instructions. Step 1. In the project window, navigate to the prefabs and go into the kitchen. Here are the prefabs and here's the kitchen. This is the only violence I can approve of. But I like you, Ember. Then, you should bring that up in therapy. Very poor choices. Very poor. Learn how to make better choices. Liking me is a lobotomizable offense. Okay, so like, that is a heckin' concern. I appreciate you all. You're all very fun. Love you all. So click and drag on the boiling pot prefab onto the stove. The scene view. Look at these cool, like, shuriken looking things. Therapy, right? That thing I definitely do. Yep, for sure, for sure. You're a heckin' concern? I am a heckin' concern. Be nice to yourself or you'll make us all sad. Well, I suppose I wouldn't want that. Suppose we wouldn't want that. Notice the distinctive icons that cover the pot. They represent the particle systems for the steam and bubbles. Oh yeah, that's true, because they're all like, whoa. Okay, that's kind of cool. Not gonna lie, not gonna lie. How did they even make water? I know that probably sounds like a stupid question, but like, for real though. Okay, so enter play mode and approach the pot to see the boiling water and steam in action. Let's do that. I like that. That's pretty. Sheath's pool noodle for now. That's funny. A sheath uwu. Sorry. Okay, next we gotta add a boiling sound. I don't know about a boiling sound, but I can add the sound of frying chicken. Now it's time to add an audio source component, which will simulate, and if anybody doesn't know what that means, that's okay. Enjoy your innocence. Enjoy your innocence. It's good. It's all right. Which will simulate the sound of boiling water. In Unity, an audio source component acts as the origin of sound in your virtual environment. In the hierarchy window, select the boiling pot game object. Boiling pot. Add component and enter audio source. This is where you specify the actual sound file you want to play. Unity allows only one clip per audio source. Use the object picker for the audio resource property to browse all available audio clips in your project. Then select the bubbling water audio clip from the list provided. Okay, so the audio resource, and then we want, what is it? Bubbling water? Yeah, we did that. Cool. To make the clip play on repeat, enable the loop property. And then enter play mode to test the new audio. So I'm gonna go ahead and pause the music, and we're gonna go ahead and give it a test. This is your quick warning for a volume warning. It should be fine. I have it turned down, but I don't know how loud it'll be. So this is just a heads up. Whoa. Bubble, bubble, toil and trouble. Wow. Now that's a pot of water. I'm glad y'all are having fun over there. That's awesome. Cool, so we did that. Make it a 3D audio source. In real life, sounds change in volume in each ear based on your distance and direction relative to the sound source. By default, audio in a Unity scene is 2D audio, which means that it stays the same regardless of the listener's position or orientation in the game world. 3D on the other hand, is spatialized. The sound changes based on the listener's position and orientation relative to the audio source, mimicking how sound behaves in the real world. Let's make the boiling pot audio clip a 3D experience. I'm actually only mildly more hinged than Lofi, but that's only sometimes. Well, she's the one in the spotlight. Yeah, sometimes you can be pretty unhinged. I think yours is in a much different way. Like yours is sort of in like a very like high energy, you're not really sure what you're doing with yourself, so you're just doing things because you have to, your body has to survive. And then, but I'm like mentally ill, should probably be hospitalized unhinged, where it's like you look at my unhinged and like, yeah, like you're laughing, it's fun, but at the same time you're like, is she okay? Like, should somebody stop her? And then everybody's like, no, she'll be fine. It'll be all right. And so you just enjoy it. It's kind of like going to the zoo, you know? I'm just like a zoo experience type of Unhinged. And then like Neko is more like the aquarium type of Unhinged. If that makes sense, hell yeah. If it doesn't, then hell yeah. Based audio is Lofi's music. That was good. Thank you. Hey, that sounds like booblies. It is booblies. It do be booblies. Pat. In the Boiling Pot Game Audio's audio source component, locate the spatial blend property and drag the slider from 0, fully 2D, to 1, fully 3D. That's kind of impressive that it can be in the middle. Enter play mode again to test it. Okay, we're gonna go ahead and pause the music. And we'll enter play mode. Whoa. Whoa. That's crazy. We moonwalk away. Can't even hear it anymore. That's pretty cool. Now we get to add background music, let's go! In this step, you'll add background music, which will set the emotional tone of your scene. The track you select can completely alter the ambiance of the scene, whether it's a calm classical piece, something more upbeat, or even something a little spooky. The Boiling Pot is meant to mimic real-world 3D sound coming from the environment. Background music, on the other hand, isn't produced by anything in the environment and is purely used to enhance the overall atmosphere of the scene, which actually is not entirely true. I have absolutely played games that contain, like, you know, a speaker object or something. Like, you know, think like Supermarket Simulator. They have like a speaker you can buy, you can put up a speaker, and the audio will actually come out of that speaker. So if you're looking away from it or whatever, or you're farther away from it, it also acts like the Boiling Pot with the 3D audio. So you can actually make background music come from somewhere, because, like, you know, you just can. But let's go ahead and set a mood in this scene with some background music. It has the AudiHD and stem with echolalia on a high level of oddness, truth. I also have that, and it just makes me talk about Gundam all the time. Very neat, very nice. My special interests change depending on the day, sometimes the hour if I'm hyper-focusing on something. Also very true. But you kind of have like a rotation you go through, I think. I think that's fair to say. Instructions. Step 1, in the hierarchy window, right-click in the empty space and select audio source. Rename it background music. In the project window, browse the available music options in the Unity Essentials Audio Music folder. What do they have? Just out of curiosity, what you got? Oh shit. Okay. Yeah. No. Whoa. We got real serious for a moment. Yeah, I like this. Whoa, this is fucking intense for doing some cooking. This is like you're like, you gotta stir. You stir. You gotta make sure the noodles don't boil, or the noodles don't burn, boil over too much, overcook, and your life is on the line. You're cooking. It's like some Hell's Kitchen type shit. That is so cool. Yeah, it's very real. I'll get into something for a bit, but then it always just goes back to robots and cards and Souls games. Hell yeah, Souls games. Yeah. Ooh, hold on a minute. Nah, this is nice. Yeah, it's like a handful of things I loop through on a weekly basis or so till I get bored with one or finish something. The relaxing one was nice. The little Pocky jiggle as you bop along was adorable. Thanks. Yes. But see, this is like you've cooked the pasta, you're assembling the plate, you're putting it together. You're putting it together. You add the noodles, you add the sauce, you add the basil, you add the Parmesan Reggiano. Merci, bon appetit. And then you wipe your forehead with the towel. You gracefully pick up the plate. You walk it all over to your company who's sitting there, waiting for just a mere bite of your food. You place it upon their table. You bow. They pick up a fork, they pick up the knife. They begin cutting into the pasta, which is a very weird thing to do, but hey, I don't judge. And then they bite. And what they taste is the most miraculous thing that they've ever tasted, and your pasta has just changed their life. Congratulations. You are now a cook. Cook like your life is at stake. Amazing. Oh my god, you really butchered whatever that was. What did I butcher? The countdown and then classicals like Great British Bake Off show, for real. Fuck, what was I doing? I can't even remember. I'm sorry. Hold on. We need to do something. We need to download. I don't have any Lo-Fi Mage music. Hi, Nick. How you doing? Thank you so much for dropping on by. I don't have any Lo-Fi Mage music on here, so I just need to kind of download. My side are killing me. Y'all got me in tears. Good. Good. What is the most chill song I have? I want something that's really chill. What do you think? That's pretty chill. This one is chill. This one's chill. I think we're going with that one. Ooh. Nah, I think this one's a little more chill. And in case nobody knew, in case you didn't know, whoever you may be now or in the future, you too can have a Lo-Fi Mage album for the low cost of free. Just go to lofimage.bandcamp.com and buy an album for the price of $0. We're gonna get it in OGG. OGG. The whole thing is just adorable. Thanks. I'm all right. I got the password to the old Android tablet finally and saw you reacted to my photos I posted. They were very, very neat. Very, very neat. Thank you for doing that. And that's awesome. Have you been able to enjoy it at all yet? Shit. I personally like Volume 1 the most. It's so good. I like Volume 1 too. Volume 1 is like, it's the most like lo-fi-ish, but then like Volume 2 is like, Volume 2 literally, like most of those songs are experiments, which I really, really like about it. Volume 3 is going to be a mix in between where it's like, I'm trying to go back to that Volume 1 vibe, but I have some experience, or some experiments in there. But yeah, so let's go ahead, and I think that was Trials that we picked. Let's just go here. Trials. Add it. Can you believe that Volume 1 was her first lo-fi song she ever made? Technically, oh yeah, technically you're right. Transparency was the first lo-fi song I made. And then the Dragon Age lo-fi one was next after that. Okay, so let me go back to the friggin' tutorial. So we have a song we want to use. In the background music game objects audio source component, set the audio resource to the thingy. So that would be the background music. There's the audio resource. We're just going to drag it in there. And then enable loop. Adjust the audio source's volume property to a more subtle level, like 0.1 to 0.5, to ensure the background music doesn't overpower other sounds in the scene. To 0.4. Keep the spatial blend as 2D. Enter play mode. Let's go. Oh, shit. Gang, that's me. My music's in the game. That's so cool. Bubble, bubble, twiddling trouble. Yeah. I'm making some fucking dank-ass pasta to my music. Let's go. I've been snooping around, but aside from using a couple apps, I've only deleted the previous owner's info. Some of the apps are downloaded and might not be available anymore, so I'm gonna copy them onto a flashcard before resetting the tablet. Very, very cool. Hell yeah. You find any juicy tea? Find any good info? Petition to add boiling water effects to the next lo-fi music. You know what? Hold on a minute. Let me... Neko, can you send me a message, please? Whether it's on Messenger or Discord. Just say... Just to add... Yeah, just add... Literally just tell me to add boiling water effects. And I will remember that. I will slip it into a song. And it will be your job. To tell... Your job, Soul, to tell me which track that eventually ends up on when you catch it. Very cool, though. Hell yeah. That is so fucking neat. Yo, that's gonna be fire, right? There's a total of 1 video, and I think that's it. Damn, was it cool? Or was it just kind of like, oh, this is lame? Is it like, you know, he's like cleaning up, like dragging a dead body out of the back of his van, and he just forgot to delete the video? You know, like what kind of, what are we dealing with here? I haven't watched it, to be honest. That's fair. Might as well stay out of his business. That's fair. Add random bird sounds outside to further enrich the soundscape of your next scene. Next, you'll add the ambient sounds of birds chirping outside. You'll achieve this effect by positioning audio sources outside the kitchen, such as near a window or in an adjacent outdoor area, and using a custom script to play bird chirping sounds at random intervals. This randomness mimics the natural behavior of birds, making the scene more immersive and lifelike. Very cool. I also vote for rain thunder sounds sometimes, but it's sent. Can you also just send that as well? Just add rain thunder sounds. I will absolutely do that. In fact, maybe yeah. You know what? I will do that. So send that as well to me, and I'll make sure that gets in some of the next upcoming lo-fi songs. Thank you. I also love Rainstorm. Like when I personally listen to lo-fi, see the thing is like I kind of try to the only like sound effects I use in the lo-fi is I use the vinyl scratch. Because when I hit, Jesus Christ, I'm having a fucking stroke. When I play lo-fi music, my preference is fireplace sounds. I really like the sound of lo-fi and fireplace crackling and stuff like that, particularly when it's really, really jazzy. And so like you can't really have, well, you can have Storm with Fire Crackle. Not entirely sure that they would go together. But at some point, maybe you get too many sound effects. So I kind of try to leave it open for the case of like, you know, someone who wants to add their own sound effects to it. Like, I think there's a site, there used to be the site, and if you Googled like, you know, like rainy mood music site or something, it'd probably come up where it will play like, you know, storm sounds in the background and you can play your music and stuff like that. But yeah, so I kind of just let people have their choice of like what background they want to add to it or whatever. But I actually think I want to design some songs around, you know, boiling water effect or like rainstorm stuff. That'd be really cool. Anyway, So let's go ahead and add these bird noises. Instructions, step 1. Thank you so much for sending those to me, by the way. Add a new audio source in your scene and position it where you'd like the sound of a bird to originate from, such as a window or near an imaginary tree. Okay, can do. So we add a new audio source. We're gonna call it bird chirping. We're just gonna kind of like from back here. And then assign the sound effects, which was back in this audio folder, sound effects. Just like this. And make sure to set the spatial blend to full 3D. To avoid the bird sound playing immediately as the scene loads, disable the play on awake property. Okay, so spatial blend, full 3D, and disable on the play awake. Select add component and then search for and add a component named play sound at random intervals. Cool. Duplicate. Oh, first let's go ahead and this is a sample script that they included with this project to test it out. So let's go ahead and go in and see what they got for us. This reminds me. Hold on. Let's wait for it. Let's go a little closer. Left ear. Very cool. That reminds me of how every Christmas we'd put on a different fireplace video on loop. My brother was young and would always be confused about how the fire kept going, so we told him that a guy puts new logs on the fireplace. Took him years to figure out that's a loop. That is so cool. I also do that, especially like when I'm like living alone or when I'm sleeping alone and then I've got a TV near me, is I will literally just put on like a 12-hour lo-fi playlist with a fireplace in it or something like that. Like that is how I like to enjoy the winter season for sure. Okay, so now we duplicate it for 2 and 3. Bird 2. Bird 3. Place them at different points around the exterior of the kitchen. Let's do this kind of like here. Yeah, I like that. For each new bird source sound source, choose a different bird sound to vary the soundscape. So for 2, let's put the second one. For 3, let's put the third one. And we'll click play. Oh, Lofi, I had a few questions. Would it be okay if I sent you a few messages on Discord later? I just don't want to be a bother if it isn't okay. You are never a bother. Please feel free to do that. That is so cool. Yeah, that's hella neat. Fuck yeah. Cool. 8. Review and proceed to next tutorial. Congratulations on enriching your kitchen scene with immersive audio. From the subtle boiling pot on the stove to the serene background music and the lively chirping of birds outside, each audio element you've added plays a crucial control in bringing your scene to life. Here are some things you learned how to do along the way. Explain the purpose of an audio source. Explain the purpose of an audio listener. Add a source of sound in the scene with an audio source component. Explain the difference between 2D and 3D spatialized audio. Change 2D audio into 3D sound for realistic spatial effects. Add background music to a 3D scene. Layer different types of audio to create a rich soundscape. See you to the next tutorial. Damn, that's cool. And now this is more things to try with the audio, which should be fun. Okay, so easy, medium, hard. Yet again, easy is going to be add a humming sound coming from the refrigerator. Medium is to source your own background music. We've already fucking done that. We've done that. Hell yeah, preemptive. I shall return when I get home. Okie dokie, artichoke. Please have a safe time getting home. And enjoy your time as well. And we will see you very soon. So 2 is add a humming sound from the refrigerator. I would like to go ahead and to try to just like blast through these to challenge myself. So in the future, if you're following along, please use this as an opportunity to like, you can either watch how it's done or please just like pause, try to do these things yourself. And then if you fail, feel free to watch me for the solution to that. But I'm going to skip reading the instructions for these audio essentials because I'd really like to just kind of test where I am at the moment. So first is add a humming sound coming from the refrigerator. So I think in order to achieve this, we're going to frame this refrigerator here. We want to add an audio source. Fridge hum, add it here. I think maybe we want to do like a 0.6 maybe. And we want to do a spatial audio 3D. Let's go ahead and try that out. Ah, I see. We forgot to loop it. I actually think the hum is a little loud. I'd like to try to balance this. Let's do 0.3. I'd like to turn it down just a little bit more even. 0.2. Danny, hello, hello. Thank you so much for dropping on by. How are you doing? And like just in case like a mod's trying to get trigger happy in a moment, I don't actually think that that's a bot. I'm not gonna lie, the name kind of look like it, but I see like actual words in there like Kali Linux, so I think it's okay, mods. I'm not a bot. Okay, good. Sorry. I just wanted to make sure. Thank you so much for dropping by. How are you doing tonight? Or morning, or wherever you are. How are you doing? So I think I'm going to turn it down just a little bit more. Ideally, I would like to be able to... Yeah, you know what? We'll lower the distance as well. Because it should be barely audible up until you get close. Just say hi in JavaScript. Well, thank you so much for coming and saying hi. I will give you... I'll give you the C# equivalent. There you go. Hello World T2. But yeah, I think... Yeah, I think that's a bit better, actually. Now, though, I do think maybe we need to turn it back up. As an audio person, I can tell one day when I eventually make my own games and try to do this kind of stuff, this is going to drive me crazy. Yeah, that's a much better hum. I'll try 300 for the drop off. 0.3 for the audio sound. Crazy enough, I still hear it though. Maybe we just have to get real strict with it. What does logarithmic even mean? See, that's my fault for not going to school. Yeah, that's much better. That's much better. You can hear it when you get close. You walk away, not all that far away, and it's gone. Standing in front of it, hearing the hum. Cool. Well, I consider that one done. Yeah, max distance and min distance and stuff. Yeah, cool. Medium, source some new background music. We've actually already done that. However, this does say to use the Unity asset store instead of my music. So just for the sake of being able to learn how to use the asset store, let's go ahead and do this one anyway. Well, audio, music. Is there a free? Oh shit, I could put my music on here actually. This isn't free. Free assets. Hold on, go back. Come on, what's your damage? Yeah, add to my assets. So shout out GWriter Studio for this 8-bit music free asset. Go ahead and open this in Unity. Download it. And so this would help in the future if anybody's watching this for game development, tutorial type help. Now y'all know how to kind of use the asset store. You got to download it. This is telling you how to import it. So we're going to go ahead and import it. And we wait. Heck yeah. Cool, and it is imported. Okay, now we just have to find it. Here we go. The background music, pick the one we like best. Nah, fuck it, I like that one. That one just feels right. I know maybe that y'all can't understand. It's okay, it's okay, it just feels right. So now we're using an asset off the asset store. We got the refrigerator hum. Boiling water, yeah. Birds chirping. Yeah, okay. Cool. Experiment with reverb zones. A reverb zone is a spatial, and Unity is a spatial audio effect that simulates the way sounds reflect and reverberates in a physical space, from echoing caverns to a soundproof padded room. Although it is not entirely necessary to add a reverb zone in this particular scene, it is very cool to see how they work and experiment with different reverb zone presets. This optional challenge is classified as expert difficulty. So in the hierarchy window, right-click and add an audio reverb zone to create a new one. This will add it to game objects here. So we'll do audio reverb zone. And then we want to, in the component in the inspector, we want to locate the reverb preset dropdown. Yep. Enter play mode and experiment with some of the presets. It says concert hall, cave, underwater, and others. Notice how all the sliders beneath the preset change with every selection. Let's do cave. What about auditorium, concert hall? Drugged. Okay, yeah, I can hear the differences. Yeah, very, very cool. And that's it for this tutorial. So now we're going to go ahead and we're going to take the quiz. Hopefully this one will load. I expected too much. So this is interesting. The next one is going to be programming essentials. That's going to be kind of fascinating. Okay, and so since we're here, we're gonna go ahead and we're gonna take a break. We're gonna probably try to get through Programming Essentials, and it will likely be the last one for the night. Because trust me, I'd love to just keep pushing and pushing and pushing, but like I also know that we need to be kind of reasonable with it. So, but for now, we've still got like another 2 hours ahead of us, it looks like. Please use this as an opportunity to grab a snack, something to drink, use the bathroom if you need, take your meds if you haven't, or even just get up and move around a little bit to help prevent blood clots, because I want to see y'all here for a very, very long time. Okay, I will see y'all back very, very shortly. Thank you so much. Enjoy the lo-fi. Okay, what the hell were we doing? No, oh yeah, that was it, We're moving, oh, fuck yeah, we're moving on to Programming Essentials. I think I might try to do something a little bit different, like going forward for the rest of these. I might try to chop it up into, like, I'm gonna redo an intro, so that way I can have this be its own, like, YouTube video thing, if that makes sense. So that way, instead of doing it by day, I can be like, oh, it's for this section. And probably help a little bit. So I'm going to try to do that. And in case you're wondering what I'm doing, I don't know. Using the wrong pewter. Okay. So yeah. Hi, I'm Lofi Mage, and this is the Unity Essentials pathway. Specifically, this is the Programming Essentials mission. And yeah, for those who are new, seeing this in the future, I am a software developer with about a decade and a half of experience in writing code. So while I'm not familiar with game development, perhaps the perspective of a, existing developer may come in handy, or may even provide some additional perspectives that would not be gained otherwise while following through the tutorial. So hopefully that's of some fun. If you don't know what's going on, please go back and watch some of the other videos. I have entire live streams that are like VODs, which can be seen by the day, or I've broken up the other videos by the mission so that you can easily follow along if you like doing the Unity stuff yourself. So with that being said, so far we've done 3 missions: the Editor Essentials, 3D Essentials, Audio Essentials, and now we're going into Programming Essentials, which I am so excited for, because this is actually where I will hopefully shine, because this is what I've been training for at the Academy. So with that being said, let's go ahead and get right into it. Let's go ahead and get started. Mission: Programming Essentials. Add code so that a player character can explore a living room and gather collectibles. What you will learn. In this mission, you'll program a simple interactive experience where you control a character in a living room scene and move around to collect objects. You'll be able to choose from a variety of characters and collectible objects. In our example, we'll use a robot vacuum that maneuvers to pick up dirt around the room. The skills we'll learn to create a game object component with a script and work with game object components. We'll learn to configure a Unity camera for a scene. We'll learn to interpret basic code and a Unity code base. That's level 1 code comprehension. And then level 1 application scripting will cultivate a code style that is efficient and easy to read. This one is probably not going to be applicable to me because I already have my own code style I've developed over the years. We'll be composing scripts that utilize various APIs. And for those who don't know what an API is, an API just stands for Application Programming Interface. And basically what it does is when we utilize an API, so someone has built a set of code that allows us to do something. We could probably build it out ourselves, but if somebody else has made the API, well, it's a faster way of accomplishing what we want to do. So maybe they built an API for using video game controllers. So we may want to add a video game or a controller, a gamepad controller to the game. And so we would want to use something like a gamepad API where it's like, we can be like, when the gamepad A button is pressed, then we can do this. That's an example of using APIs. And we will learn how to control the execution of code with common logic structures. I'm guessing this is probably going to be things such as, like if and then statements, which is, like if a character has 0 HP, then they are fucking dead. I'm imagining it's probably going to be something like that. So let's go ahead and get started, shall we? Looks like the first tutorial on this is going to be add a movement script. That should be fun. Please do not error out. Yep, okay, yeah, that about tracks. Hopefully it will not stay this way. Although I have a feeling we may get unlucky here. That would be kind of sad. Oh, brother. Is it just going to be the whole site? Yes, it will. That's actually kind of crazy. Okay, hopefully it'll work for a moment. It's really cool that we're almost halfway done though. Okay, gonna have to cut this out of the VOD. Damn. Okay, but we're here, so hopefully this can be enough. Add a movement script is the first tutorial. Neat. Select a player character and create your first script that allows you to control it in the scene. One is the mission overview, which we will watch. In this mission, you'll program a simple interactive experience where you control a character in a living room scene and move around to collect objects. You'll be able to choose from a variety of characters and collectible objects. In our example, we'll use a robot vacuum that maneuvers to pick up dirt around the room. So let's go ahead and give the music a pause and we'll watch.
Learning to program in Unity opens up limitless possibilities for interactivity, allowing you to develop unique and engaging experiences. Depending on the code you write, you can make a puzzle game, an action adventure, a product configurator, a VR simulation, and so much more. To learn the essentials of programming, you'll bring an interactive living room scene to life, where the user controls the character to collect objects. First, you'll create a script using some provided code that allows you to steer your character around the room.
That's neat.
Next, you'll write your first line of C# code from scratch to make a collectible object rotate, learning about key programming concepts like data types and variables. Then, you'll dive deeper into scripting by making the collectibles disappear and spawn a particle effect when the player collects them. You'll need to learn about new functions and if statements to achieve this. Now, let's jump in and start coding.
Cool. Yeah, sounds like a plan. Let's do it. Tutorial overview. In this first tutorial, you'll add your first lines of C# code to your Unity project to steer your chosen character around the room. So first is to open the programming scene, or the third step, but the first thing we should do, is to open the new scene for the mission, which is a simple living room environment. Instructions, step 1, is in the project window, navigate to the Unity Essentials Scenes folder. And load up number 4. Adjust your view of the 3D scene to see the living room interior from a good angle. Go. Yeah. Great. Add a player to the scene. The next step is to add a player. The player is the character that the user of your game will control. In this living room scene, your player can be one of the following: a robot vacuum sucking up dirt, a toy car getting stars, a wind-up mouse finding cheese, an alien in a UFO collecting gemstones. It's up to you to decide which one sounds the most fun. I think we'll do a wind-up mouse finding cheese. What do y'all think about that? Is that cool with y'all? Because I kind of like the sound of that. So the first thing we have to do is go to the prefabs and then characters. And there's the mouse, so click and drag your chosen character onto the scene near the main door on the left. Sounds cute. I like cheese. I like cheese too. Warning, avoid double-clicking the prefab in the project window because this will open prefab editing mode. Instead, simply drag and drop it onto the scene. Okay, if necessary, rotate the player by 90 degrees on the y-axis so that it's facing the center of the room. In the hierarchy video or window, rename your chosen character player for clarity. Oh, that's cute. This is very, very adorable. Cool. Create a new player controller script. It is time to create your first C# script. C#, pronounced C#, is a versatile programming language that is widely used for developing a broad range of applications, from web to mobile to game development, and particularly with Unity for game scripting. Your first script, which is just a document with code in it, will be named Player Controller. In this script, you'll define how your player interacts with the game world. In the project window, navigate to Unity Essentials Scripts. There should already be a folder inside the Scripts folder named Provided Scripts. Ignore it for now. Right-click in an empty part of the Scripts folder and select Create Mono Behavior Script. Go to Unity Essentials Script, and then we'll create a Mono Behavior Script. And we're gonna name it Player Controller with a capital P and C. Okay, come on. Come on. It's important to get the correct name, or the name correct right now, and renaming it later can cause problems. You'll see the code, Kapound. What about Kapound? The pronunciation. You'll see the code of the new blank script in the inspector window. Notice that the name of the file is included in the code. That's why it's important to spell the file name correctly. Oh yeah, I see here. Because see how it says public class new mono behavior script? So let's just go ahead and delete this. We'll recreate it again and just name it, you know, player controller. Right from the get-go without looking. And now it says public class player controller. Cool. So we'll go ahead and yeah, no, if you make a typo in your script name or have to rename it for any reason, it will be easier to just delete it and create a new one with the correct name. I'm very glad they specified the pronunciation. It could have been C anything, right? Well, there is C++. There is just C as well. It could, and you never know, someone young enough might be like, oh, C hashtag. So now we apply the script to the player game object. Here's the fun fact. In Unity, the scripts you write in C# are components, similar to the rigid body, audio source, and other components you've worked with. The difference between the components you create and Unity's built-in components is that your custom components are editable. Step 1 for the instructions. In the project window, find the player controller script you created in the scripts folder. Oh God, it's making me feel old because my first was £. Yeah, you should. No, I'm just kidding. Click and drag the script, onto your player character in the scene view. Nothing will appear to happen after you do this. Okay. Showed up right there as a new component. Yep, and then verify that it was added and then save. Cool. Open the player controller script in a script editor. Unity doesn't allow you to edit code directly in the Unity editor, so your next step is to open your player controller script in a separate script editor application. You may not have realized it at the time, but when you installed Unity, you likely also installed a separate application called Visual Studio, which is a code editing application, also known as an Integrated Development Environment, or IDE. This IDE is where you'll start coding the behavior of your player character. A script editor, such as Visual Studio, provides you with tools and features to write and manage your code efficiently. Now, for anybody in the future who this may be relevant to, Visual Studio is not the only IDE you have to use. You can also use JetBrains Writer, which is what a lot of actual people developing games recommend. You can also try to rig it so that you can use Visual Studio Code, or even something like if you do the whole vibe coding thing, you can rig it so that you can use Cursor. You can kind of do whatever you want, really, but the easiest options are going to be Visual Studio or JetBrains Writer, because you will be able to find instructions on how to do it for both. However, for the sake of just it's going to be whatever we end up double clicking, basically. So let's go ahead and do that. So now it's going to let us choose. I'm going to choose JetBrains Writer. Although here, let me riddle me this. Let me go ahead and just download Visual Studio Code. Should only take a moment. Yeah, just because it's going to be the fastest for me to edit things in. I'm going to pick Visual Studio Code just once, because this is basically more or less the text editor, right? However, you also have to do a bunch of things like install the C# dev kit and yada, yada, yada. And there's a lot that you have to do. Well, maybe not a lot, but there's extras you have to do to get started. So it's just easier to use Visual Studio or JetBrains Writer or whatever that they want to do for you. Cool. So now we can continue. Double click the script. Yep, we did that. When the IDE opens, you'll see the default starter code that generates anytime you create a new script. Great. So we did that. Copy and paste code and save. In this step, you will infuse life into your player character by adding some pre-written code to the player controller script. This code contains the logic for player movement. To start, you'll copy and paste all the code from a completed script, overwriting the code already in your script in its entirety. Later on, you'll take more time to understand the code and write it line by line. Copying and pasting code, then adjusting it, is actually a big part of every professional developer's workflow. That is absolutely facts. Okay, instructions. In the IDE, in the player controller.cs file, select all the code by either clicking and dragging with your cursor or by pressing Ctrl A and then deleting it all. Select all of the code below and then copy it with Ctrl C. And then in the script editor, you can now paste it. Ta-da. Save your changes. There should be no errors in your code. And that's the thing where using something like Visual Studio Code may get you in trouble with. Visual Studio and JetBrains Writer are going to be infinitely more likely to be better at catching these things, like the red lines if there are errors in your code. Like, what happens if we just do that? Yeah, see, that doesn't even detect it. Same thing, doesn't even detect that an error is happening, so. And then in the Unity editor, enter play mode and move the player with the arrow keys, or with the WASD keys. So, welcome back. How you doing? And you know what? Honestly, I can walk us through this code. Shouldn't be too difficult. So, here's what's going on for you know, since I might as well make my experience useful to y'all. So at the top, we have a using statement. Basically what this does is it imports the Unity engine namespace or API. We're creating a new class called player controller. A class is just a way to organize code, essentially. And the player controller class is basically derived from mono behavior. Player controller is a mono behavior, you could say. Then we have a few variables, 2 public variables, which means that I'm pretty sure they can be modified inside of the editor here. Yeah, speed and rotation speed can both be edited, and they are publics. And they are floats because they're using decimal numbers. Rigid body is a reference to the physics component here, the rigid body component. That's just all that means. When the this function start is called before the very first frame even gets to the user, so the very beginning, we basically load that rigid body component into this RB variable. And then there's an update that's empty, and then there's a fixed update which contains code. So I think from my understanding is that update is called once per frame, but that is not necessarily reflected in what the user sees. Fixed update you specifically use to handle the physics-based movement and stuff because, or no, maybe I'm incorrect. Maybe fixed update just does have to be physics-based stuff and it's specifically for that because that's what the Unity engine requires. So I'm not even gonna attempt to describe it, but obviously from what it says here, you'll wanna put all the physics-based movement and stuff, physics-based code into fixed update. Everything else can go into update. I am assuming that that's kind of true going forward. And good, I'm so glad to hear that you're doing all right. Hopefully now that you're home can be an even chiller vibe. So now we want to set the camera as a child of the player. Right now, the camera is stationary, making the experience feel a bit distant and potentially confusing for actual control of the player character. Now you'll position the camera to follow the player in a third-person view, which will be more immersive and intuitive. If you make the camera a child game object of the player game object in the hierarchy window, it will inherit the player game object's position and rotation, and also maintain a steady view of the player as it moves. So step 1, we locate the main camera game object, and then we drag it onto the player character. In camera, drag it on, and it is now a child of the player. In the transform component of the main camera game object, we can reset all of the position and rotation values. So we can just literally just reset it all. Yeah. In the scene view, adjust the camera's position to be slightly above and behind the player. So slightly above and behind. And then we can press play. Oh, we can also use the preview panel to make sure that the player appears in the camera's view. Where is the preview? Is that this? Yeah. Just like that. The mousey is cute. It is very cute. There we go. Cool. 1 second. Number 10. Edit player properties in play mode. Editing player properties in play mode is a dynamic way to fine-tune the behavior and characteristics of your player character while observing the immediate effects of those changes. Important though, remember anything you change while in play mode is temporary and will not be saved. To save your changes, you'll need to exit play mode, make the edits again, and then save your scene. So what it's going to have us do now is to select the player character, and then in the inspector window, once we're in play mode, it's going to have us change the speed and rotation speed. And then we're going to just kind of fiddle with them around. So let's change the speed to like 3. Yeah, that's a lot better, I think. Maybe even 2. Change the rotation speed to like 100. Yeah, I like that. So 2 and 100. And then exit play mode and then put them back. So 2 and 100. Done. And then now proceed to the next tutorial. Congratulations on adding your first script to control the player as it navigates through the room. Here are some things you learned how to do along the way. Explain how code is edited in a Unity project, make a new script component, add a script component to a game object, open the IDE from the Unity editor, assign a camera as a child object that follows the player, and adjust component properties temporarily in play mode. Next one is creating a rotating collectible. Very cool. Huh. It's weird. We'll just try to go to it ourselves, I guess. All right, come on, Unity. Bruh. They really do be having problems tonight? Yeah, absolutely. Yeah, that's kind of hardcore. Bruh. I think this song is my favorite. Every time I hear it, it sucks me in. That makes me so happy to hear. I really like this song too. Okay, there we go. Fuck, finally. Create a rotating collectible. Program your first line of code from scratch to make your collectible object rotate around its y-axis. Overview. In the last tutorial, you copy-pasted code into a new script, which is a great way to start. In this tutorial, you'll write your first line of code to make a collectible object rotate in a scene. These rotating collectible objects will be the things that your player character tries to gather throughout the living room scene. When you're ready, proceed to the next step. 2. Add a collectible game object in front of the player. The first step is adding a collectible item in front of the player. You'll probably want to select a collectible prefab that makes sense with the character you've chosen. For us, it's going to be cheese. In the project window, navigate to Unity Essentials, Prefabs, and Collectibles. Oh wow, there's money, music note, puzzle piece, that's so neat. Tonic. Let's do cheese. Drag and drop your chosen collectible prefab onto the scene directly in front of the player. Adjust the collectible's rotation position and scale to ensure that it's easily visible and reachable by the player. This will make testing as efficient as possible. Oh, come on. Or it should be fine, I think. Yeah, that's big enough. Create and apply a new collectible script. In this behavior, you'll create a new empty script. This script, which you'll name collectible, will govern the behavior of the collectible objects you've added to the scene. So we want to go to the scripts folder. We'll want to make a new script and call it collectible. Collectible. And now we want to select it in the hierarchy. So collectible cheese, and then drag and drop the script onto it. There it is. Review the structure of the default script. Before you start coding, take a minute to review the structure of the default script you've just created. This might feel overwhelming at first, especially if you're new to programming. It's important to remember that understanding the nuances of scripting is a gradual process, and it's entirely normal to feel a bit daunted at this point. So don't worry about that and trust that it will all slowly start to make sense over time. And this is a very, very true statement. Like for anybody who's watching this now or in the future, thinking about, scripting, programming, whatever. Like I literally have been programming since I was a child, an actual child. And even learning all of this new information is still daunting to me. Anybody who's truly invested in learning, that never goes away. But that is also like a very fun feeling if you let it be, because you start to get good, you start to understand, you start to know exactly what you're looking for and wanting to do, and you can really do some cool kick-ass stuff. So don't let the fact that it's daunting stop you, because you can overcome it, you will overcome it. And then you'll start kicking ass. You'll kick all the fucking ass. But anyway, so the instructions, we want to double click the collectible script to open it. Locate the using statements. Yeah, we've already went over those. So if you need to review this a little more, please pause, read it, or go to the Learn Unity and then read about it yourself. I'm gonna go ahead and move on because I already went over this stuff verbally myself. So yeah, the start function and update function really are the most important things you need to know. The start function is executed once at the beginning of the game. The update function is ran once per frame, generally between 30 to 60 frames. Although y'all know that games can go to 120, 240 frames per second or whatever. So, in the future, when you start making games, you'll need to be cognizant of that and make your code fairly efficient to run so many times per second. That's why doing everything right from the beginning is so important. So 5, plan your rotation code. Before writing your first line of code, let's take a moment to understand what you're actually trying to do in your code. You'll experiment in the scene view to visualize this. Select the collectible object and frame it in the scene view so you have a good view of it. Let's go ahead and do that. Gang, I'm really eepy. You should go to sleep then, hun. And you should try to get some rest. Yeah. Back, what are we doing? Make sure you're using the local coordinate system instead of the global system, so you'll be able to see the orientation of the collectible changing as it rotates. Let's go ahead and do that. In the inspector window in the transform component, locate the rotation coordinates. Click and drag the label Y right and left to change the Y-axis rotation. Now we're watching it spin. Okay, have a good night. Thanks for being so cool and silly and cozy. You're very, very welcome, and thank you so much for coming by and hanging out with us like you do all the time. Have a good night and sweet dreams. Oh, and then if you hold shift, it'll change more quickly. That's neat. That's good to know. So it says, observe how the object rotates in the scene view. This visual experiment helps you see the effects of rotation values on your object. This is the effect you want to achieve in your script. You want to increase the Y rotation value in the transform component continuously over time. In the next step, you'll add the code that rotates the collectible around the Y axis continuously. So 6 is to add your first line of code to rotate the collectible. It's time to add continuous rotation from your collectible script. You'll do this by manipulating the object's transform component, which controls the object's position, rotation, and scale in the scene. Specifically, you'll use the transform.rotate method, a built-in Unity function that makes an object rotate in 3-dimensional space. For a simple rotation effect, you'll change the Y value, which makes the object rotate around its vertical axis. When you put this rotate code in the update function, the collectible will rotate a little bit each frame, making it appear to smoothly continuously update. So you're going to open the collectible script. You're going to go inside of that update function and put your cursor inside the update method between the sets of the curly brackets. Add some extra space if you need it. It won't hurt nothing. And then we're going to write this code here, transform.rotate. And I'll just type it manually so y'all can understand. I can explain what it does. And actually, I guess that is a good reason for me to use like Visual Studio Code or something. What is this? C# and Unity specific features are not available when the project is opened as a folder. Please close and reopen through the Unity editor or by opening a .sln file. Make sure JetBrains Writer Editor is installed in Unity's package manager and Writer 2025.1.5 set as this. Okay, go ahead and do that. What the fuck is the external script editor then? Writer flow. I don't think that's what we're looking for. Okay. We already got it. Great. And then we'll need window package manager for Unity. Push to packages, Unity registry. Then we'll need JetBrains. Cool. Cool beans, cool beans. Alternatively, install the engineering feature using the Unity package manager. Interesting. Start using JetBrains Writer with your Unity project. So we'll want to go to the external script editor. Now we should be able to go into preferences. Yeah, and select writer. Okay, cool. So now it looks like... Yeah, now it looks like we have full... Okay, so... in that update, we're... I'm just trying to let it load. It's like IntelliSense or whatever. IntelliSense is where you begin typing and then it tries to like auto-complete. But it taken a moment. Oh yeah, so it's taking its sweet precious time. So I can explain it without IntelliSense, it's fine. Transform.rotate and then three digits. So what this is doing, transform is accessing the transform property of the game object it's attached to. Rotate is saying that we want to rotate the transform. Just like the physical properties of the object. We start the parenthesis to begin passing in parameters. And then that's going to be X, Y, and Z. So we don't want to rotate the X. We want to rotate the Y by 1. And then we don't want to rotate the Z. And we close it. So now we're going to enter play mode and it should just be rotating. Yeah, it rotating. Reduce speed to a decimal float value. This basically slows it down. You might notice that collectible rotates really quickly. However, if you try to reduce the value from 1 to 5 in your script, you'll get an error in your code indicated by a red underline. In C#, decimal numbers are treated as float values. A float, short for floating point number, is a data type that can handle decimals. Data types in programming specify the type of a value and how the computer interprets this value. For instance, integers for whole numbers, floats for decimal numbers, and strings for text. When you use float values in C#, you need to explicitly indicate it's a float value by putting an F at the end of the number. So we're going to reduce from 1 to 0.5. And the way that we do that is in our script. We just replace the 1, 0.5, and then we add an F. That means that we are using a float number. Because otherwise it tries to interpret that as a whole number, and you will either, depending on what the number is, I think, you will either lose the number entirely because it will round down to 0, or it will round up to 1 and you won't get what you're intending. So now if we go ahead and play it, it rotates a lot slower. And we'll put the y-axis at 0.22. So we should still be able to grab it that way, but it won't sink through the floor. Declare new rotation speed variable. In this step, you will enhance the flexibility of the rotation behavior by introducing a public variable to your script. A variable in programming is just a named piece of data that can vary. When you declare a public variable for rotation speed, you'll allow yourself and anyone else who works on this project in Unity to easily adjust the rotation rate directly from the inspector window without the need to modify the script. This practice is an example of efficient game programming. So first, we have to open up the collectible script, which we've already done, above the start method, but after the first opening curly bracket of your script. Use the enter key to create a new few lines if you need to. And then declare a new public float variable before the start method by adding the line public float rotation. So basically, within the class, like right after the class is where you start defining variables. So public float rotation, and it wants us to say rotation speed. So this creates a public variable named rotation speed of type float. The word public, as opposed to private, makes this value editable in the inspector window. Using a lowercase letter for the first word, but uppercase letters at the start of all subsequent words, or words that come after the first, is known as camel case and is a common practice when naming variables. That's true. It's called camel case because it kind of looks like a camel from the side with humps at the center of the word. Now replace the hard-coded rotation value in the update method with this new variable you just created. So instead of this 0.5f, we'll just use rotation speed. Save the script and switch back to the Unity editor. In the inspector window, you'll now see the rotation speed variable in that window when you select the collectible object, which is set to 0 by default. You'll also notice that Unity has taken your camel case rotation speed variable and changed it to rotation speed, as in like proper, being grammatically correct for improved readability. So if we go back to Unity and we scroll down on our collectible and go to our script, you can see here now we have this cool rotation speed variable that we can set right here without having to go back to the code. And we could just set that to 0.5, which is what it was at. So if we go back to play mode, oh, that's fucking us up. But yeah, and then we can scroll down and we can speed it up, make it reverse the opposite direction. We can slow it way down. Or whatever we want to do, bro. This music going on is so good. Thank you so much. I'm glad that you like it. and then we'll save. Congratulations on writing your first line of code to make the collectible rotate about the y-axis. Here are some of the things that you learned along the way. Explain the using statements at the top of a Unity script, identify a class declaration in a script, explain the mono behavior class in Unity scripts, explain the start and update functions in a Unity script, call a transform function in the update method to transform a game object over time, apply correct data types in code, including integers and floats, declare new custom variables in a script, explain how public variables in a script behave in Unity, describe common naming conventions, including Pascal case and camel case, apply correct naming conventions to variables and methods, and now we can proceed to the next tutorial. If it will let us. Oh, this is gonna be interesting. Okay, next step is to collect the collectible. Make each collectible disappear and spawn a cool particle effect when the player gets it. In the previous tutorial, you wrote your first line of code to make a collectible object rotate in the scene. In this tutorial, you'll complete the interactive living room scene with more code that allows the player to pick up the collectible object, rewarding them with a satisfying visual effect. You'll also add more collectibles throughout the room to complete the scene. When you're ready to get started, go to the next step. Yay, actually coding in a game, right? Allow the player to go through the collectible. Right now, the collectible is like an immovable rock. It won't budge when the player collides with it at full speed, and it even knocks the player off of its course. You need to set up the collectible so that the player can pass through it without any visible physical collection or bump. You can achieve this with the isTrigger property of the collider component. When you tell a collider component to act as a trigger, instead of a physical collider, it will no longer have a solid barrier, but it can still detect entry by the player or other game objects. A trigger collider makes an object act more like a cloud. Even though it looks solid, an airplane can still pass right through it, and the pilot knows when they've gone through it. Instructions: first step, make sure that the collectible is positioned in your scene so that the player can run into it. 2, enter play mode and try to collide with it, which we've already done, it fucks up the player. Step 3, select the collectible object and locate its collider component. Step 4 is enabling the isTrigger property. So here's the collider, just check isTrigger, bada boom, bada bing. Enter play mode to test it again. We should be able to just run right through it now. Yep. So there we go. Add the onTriggerEnter function. In this step, you'll write code to detect when the player makes contact with the collectible. You'll achieve this in your script using the onTriggerEnter function, a special Unity function that is called when one object enters a trigger collider zone of another object. It's important to note that the event is only called if at least one of the objects involved has a rigid body component attached to it. The player object already has a rigid body component, so you're all set. Instructions: step 1, reopen the collectible script. Step 2, after the update method, but before that class ends, create some space if you need. And then begin creating this onTriggerEnter event. If your development supports it, you should see very helpful autocomplete suggestions. That's kind of what I was saying, where we could, right after the update, we got private void onTriggerEnter, and then it pops up here for us. It just kind of autocomplete like that. Any code that you put in between those two curly brackets will run. I just realized. There we go. That should be readable. Any code that you put in between those two curly brackets will run when an object with a rigid body component collides with the collectible. In this case, you want to make the collectible disappear, which you will do next. One thing that is Really useful. You can use console.writeLine and it'll write stuff to the log, I'm pretty sure. So console, the console right here. We just open that up. We go here. But it's a little weird that it's not. Huh. Yeah, that's interesting. Let me see. This is actually useful info to know. If we go to Unity console log. Ah, so it's a debug. So it's recompiling and what have you. We'll press play. See, now collectible entered. Anytime we enter the collider there. So that's how you log stuff to the console in case you need to print yourself, you know, some information. So now it's going to teach us about writing comments. It's going to be, honestly, it's going to be faster for me to just explain it. So basically in your method, and you could write code comments anywhere. It's just on a line, or even, so if you're on a new line, you could just type // this is a comment. If you want to do it after something, so after the semicolon of something, you can // this is another comment. There you go. Now you know how to make comments. So right here, we want to destroy the collectible. So step 5 is destroy the collectible. In this step, you'll make the collectible disappear when the player interacts with it. You'll use the destroy method in Unity, which removes game objects from the scene. This will make it seem like the player has collected the object. Inside the onTrigger method, press enter to add a new line beneath your comment. Begin to enter destroy and notice that your code editor may provide autocomplete suggestions. And we'll want to do the destroy game object. The game object here refers to the game object the script is attached to, which in this case is your collectible. Also note that game object starts with a lowercase letter here, camel case. So we'll just want to do destroy game object. Now we go back to play and we can test it. Just like that, disappears. Ta-da! Now we can explore particle effect options. You probably noticed that collecting the object was not very satisfying or obvious. You could barely tell it was collected. When the player accomplishes something, they should get some kind of visual feedback to make that clear. Simple visual effects, VFX, like puffs of smoke or mini explosions, are one of the most effective ways to provide this visual feedback. In Unity, you can use particle systems to simulate complex visual effects, such as fire, smoke, or a burst of sparks. In this step, you'll select the particle system to provide visual feedback for your collectible. Instructions, step 1, navigate to Unity Essentials Prefabs VFX folder. Here's the VFX folder. This folder contains pre-made 2D and 3D visual effects that you can use in your scene. You'll use the non-2D effects for this project. Double-click the various 3D particle system prefabs to preview them in prefab editing mode. Inside prefab editing mode, you should see a particles panel that allows you to restart and preview the particle effect. Oops, didn't mean to double click. Right? Oh no, we do want to double click. We do float up. We do splatter. I think I like float up though. So now we can exit it, because we're going to use float up. Create and assign a new variable for the particle. Variables store data that you can reference and manipulate in your code. For example, you made a float variable for the rotation speed of your collectible in the previous tutorial. Variables aren't just limited to numbers though, they can be any data type. You even have game object variables. In this step, you'll create a variable of type game object to reference your chosen particle effect prefab. Later on, you'll be able to reference this variable to spawn your own particle effect in the scene. So for the instructions, step 1 is to open the collectible script, which we do. Below your rotation speed variable near the top of the script, we need to add a new line that declares a new public variable of type game object. So we'll just do public game object. This time it is capitalized, and then on collect effect. You can name it whatever you want, but something like onCollectEffect makes sense. This variable will hold the reference to your particle effect prefab. So now we gotta save our script and go back to Unity Editor. Select the collectible game object that your script is attached to. You should now see the onCollectEffect variable in the game window. You'll notice it has the value of none. Very true. You need to tell Unity what prefab game object you actually want to use as your collection effect. So we'll just drag the prefab over to that, that variable, like so, float up, drag it onto the onCollectEffect where it says none. Now that is selected. But if we enter the play mode, now the particle effect won't generate. We still have to add the code to do that. 8, instantiate the particle. Instantiating an object in Unity means creating a copy of it during runtime while the application is running. You're making a new instance of that prefab in your scene. Just like the transform.rotate method you used earlier required a rotation value for the X, Y, and Z axes, the instantiate method also requires certain information to execute, separated by commas. Specifically, you need to add the following information, or specify the following information: which object to instantiate, the position and rotation of the instantiated objects. In this step, you'll instantiate your chosen particle effect when the player collides with the collectible. So the instructions: 1, inside that onTrigger enter method, press enter to, after the destroy command to make room for new code, however much space you need. Then add the instantiate code as it is shown below. Feel free to also include the comment. So for a teaching moment in how to, read, work with autocomplete and stuff. So we're gonna do the comment first, instantiate the particle effect. And then we're gonna do instantiate, see how it's popping up. And then on the right here, like it has autocomplete here, what it thinks it wants, which is very true. I think it knows exactly what we want, and it's guessing very, very well. But over here on the right, you can see the different ways that you can use instantiate. You can give it just the object, you can give it the object and a scene, an object, and then the transform stuff, or like so many different things. You can give it a vector 3 position, and then quaternion rotation stuff, which I believe is exactly what we're going to do. We're going to do it like instantiate on collect effect, transform position, transform rotation. And then we will go to play mode. And now we should see the particle effect appear. Ta-da! Okay, 9. Create an interesting path of collectibles. With your collectible now completely functional, you're ready to populate your scene with more of them. We'll provide you with a few pro tips for efficiently creating a straight, evenly spaced path of objects in your scene. In the scene view, make sure you are using the global components so that you can move the objects in a straight line relative to the world's coordinates, regardless of which way the object is facing. So we'll just end game mode, we'll save, go to global. In the hierarchy window, double click the O3 living room game object to frame it, and then use the scene view gizmos to switch to the top view to get a better perspective for arranging the collectibles. It's like that. Use the top view. Select the move tool, then select your collectible. We already have the move tool. Here's our collectible in the hierarchy window, the collectible cheese. We're gonna do Control D or Command D on Mac to duplicate it. The duplicate collectible will be at the same position, so you won't see it in the scene view, but you will see a copy appear in the window. To move the duplicated collectible along a specific, XYZ axis, click and drag one of the arrows of the move tool. To ensure that collectibles are evenly spaced, hold down Control while you move the collectible. This ensures snapping so that you can place the collectible at fixed increments along the chosen axis. So we'll go ahead and Control D. And what did it say? It said to do drag while holding Control. And then duplicate it to collect a series of collectibles, forming a path or pattern. Okay. Now try to collect them all. Jeez. Jace. We got that. That turn. Got that one. Go underneath. Through the couch like that. Yeah, just like that. Ta-da! Number 10 is restrict collisions to the players only. When you spread collectibles around the room, you may have noticed something strange. Collectibles disappear when they collide with one of the chairs. If you haven't already seen the problem, try putting one of the chair's legs or the couch on top of one of your collectibles and hit play mode. You'll see the chair trigger the destruction of the collectible. To fix this, you'll need to adjust the logic in the code so that only the player can trigger these events. The logic in the collectible script needs to be when an object with a rigid body component collides with me. If that object is the player, then destroy myself and spawn a particle effect. To add this logic, you'll use an if statement to check if a certain condition is true, and if that condition is true, then continue to execute the code. You'll also use a feature in Unity called tags to identify the player game object. So let's try to see an example of what the fuck it's talking about. So there should be this cheese here, it should hit the chair leg by the time we get over there. I guess it's not going to. We can make it do it though. Yep, see? It poofed over there. So now let's go ahead and do what it wants to do. Select the player game object. Open the tag drop down at the top of the inspector window and select player to apply that tag. Here's player. In the collectible script, use enter to add some space above the destroy command and add the following if statement. If other dot compare tag player. So when it says above the destroy command, just asking us to, you know, like right above here, if other dot tag equals player. We don't want that. If other dot compare tag player. Debug. We'll say, we'll actually delete that. We'll put it in here. Collectible entered by player. Remember, this code defines properties of the collectible, so other refers to another object that has collided with this one. With that in mind, here's how you can read the code above. If the other game object that has collided with me has the player tag, then execute the code inside the brackets. Select the destroy and instantiate code below, and then cut it and paste it. Now your code will only run if this is met. So when we play, we should not see that cheese disappear. Yep, and then cheese is fine, but we can still collect all the cheese. That chair. And I'm gonna show y'all something that's a really neat trick. So this looks a little bit messy, to be honest, because we're putting a bunch of logic in this, you know, oh, if the other has the tag of player. But instead what we can say is, if the other compare tag player, and what we can do, motherfucker. If the other tag is not player, then we can return and do nothing. So then now we can take all of this code out and we can put it right underneath. And we should still get the same effect, because if the colliding object is not the player, we're not doing anything. We're just holding up. See over there? Yeah, cheese ain't doing shit. But if we do shit, the cheese do shit. See? We made that look a lot cleaner this way. Now we have to declutter the hierarchy. You now have a lot of collectible objects in your scene, and the hierarchy window is getting very cluttered. Take a moment to organize the hierarchy using an empty parent game object. So basically we're just creating the empty parent, doing that thing again. We're selecting all of the cheese, creating an empty parent, and we're just calling it collectibles. That's done. And now proceed and review and proceed to the next tutorial. Congratulations on completing your interactive living room scene by setting up collision detection for your collectible and triggering VFX feedback. Here are some of the things you learned along the way. Set up a collider as a trigger instead of a physical boundary. Apply the on-trigger-enter function to detect collisions with other objects. Devise comments that describe a given block or line of code. Apply the destroy function to remove objects from a scene. Code quickly using the autocomplete feature of the IDE, if that applies. Explain how visual effects, VFX, can be used to give the user visual feedback. Declare a variable with the data type of game object. Apply the instantiate function to spawn prefab instances in a scene. Apply snapping with the move tool to align and evenly space out game objects. Apply if statements to control the logic and flow of the script. Apply tags to game objects in order to identify them in a script. That's it. Now we can move on to the more things to try. Further develop your project and skills with optional challenges of varying difficulty, of course. Easy, medium, hard. Easy is add a jump ability. Medium is make the door open when the player approaches. Expert is use generative AI to add multi-camera toggling. Now that's interesting. I don't even know what it means by that. So first is to add a jump ability. Let's go ahead and do that. I'm going to go ahead and do this myself. I'm gonna try to do it myself anyway. And so this is your opportunity to pause, do it, come back, and then you can compare if you'd like. So yeah, with that said, let's go ahead and get it done. Yeah, I just totally read it ahead of time. That's my bad. To be fair though, it looks like it involves mathematics and what have you, so maybe it's for the best. So yeah, open the player control script in your editor, add the following declaration. I'm just gonna copy paste it. Stop. The jump force after you save, yep. Between the opening and closing curly brackets of the empty update function. Oh, this is this is for the player. For the player. Just go in here and we can open up the player controller right there. So, in the update function, if input get button down jump. Yeah, it already knows what it wants us to do, but instead of force mode.impulse, we'll do velocity change. Add an instant velocity change, ignoring its mass. Well, what was the impulse? Add an instant force impulse to the rigid body using its mass. Interesting. Well, let's try velocity change. So basically, it checks if the jump button is pressed. Jump is configured in Unity's input manager to correspond to a key or button press. By default, the jump action corresponds to the spacebar. RB is a reference to the game object's rigid body component used to apply physics. RB.add force, vector3.up. Interesting. Times jump force, force mode.velocity change applies an upward force to make the object jump. Vector3.up indicates the upward direction, and jump force sets the force magnitude. Force mode.velocity change changes velocity directly, making the jump instant. So let's go ahead and see how that plays out. Oh yeah, there we go. We just gotta like put that cheese up in here. Oh God. Oh no. It's a bug. Oh God. Oh, it works. And just because I'm curious. of why it wanted to do impulse first. We're gonna change it to impulse. We're gonna rerun it so that way we can actually see what the difference is. Baby's first bug for real. Bug mouse. Fuck. No. Hey, we got on the table though. That was what I intended. Okay, oh, so we did that. Medium, make the door open when the player approaches. The player is currently trapped in the living room. It would open up so many possibilities if the player was able to open the doors and enter other rooms. You could even connect the living room with the kitchen and the kids' room and allow the player to explore all three environments. That is so fucking cool. To allow the player to open the door, you'll need to add a new script that makes use of the Unity's animator system. You may not have realized this, but you can actually create animations directly in Unity and then trigger those animations via script. The door game object already has an animator component with a door open animation attached to it. You need to add the script that tells the animation to start when the player enters a trigger zone of the door. So first we need to create a new script called door opener. In the scene view, select the door on the right side of the living room. Does it actually have a... Doesn't look like it has an animated thingy. Or I guess it's just already created. The door game object. Ah, I see. The parent game object is the one with the animator component attached to it. Oh, I see. Yeah, select the door on the right side of the living room, and then in the hierarchy window, make sure that you've selected the parent door game object and not the child door panel or door handle game objects. Yeah, it makes sense. Okay, so now we add component and then search for and add your new door opener script, although we can just kind of drag that right on here. We can open it up. Delete all the default code and replace it by copying and pasting the code below into the empty script. Feel free to read it to see if you can understand it with help from the comments. When you're done, save it and return to the Unity editor. So let's do it, and then we'll go through it. So we set up a animator variable called door animator. We set it to private because we don't want to access it in the editor. When the game begins, set the door animator to the we set the door animator variable to whatever the animator component is. We're basically just linking them together so that this script knows what the animator actually is and can use it. And then on trigger enter, which is the collider. When we add a collider, we check if the other trigger entering the trigger is the player, or if the object entering the zone is the player or other specified object. Make sure the player game object has the tag player. We're going to do the same thing. We're gonna say, if it's any other game object than the player, return. Then if the door animator is not null, which means if we were able to successfully grab it at the start, then we can set the trigger for the door to open. So Now, with the door game object still selected, we need to add a new box collider and then enable the is trigger property. Okay. In the box collider component, select edit collider, then use the scene view controls to set the size and position of the trigger zone. We're going to extend it beyond the realm of the door a little bit. We're going to look from a top-down perspective. We're going to drag it beyond the door. That way it should open with, you know, some space. And that's it. Now we can enter the play mode and we can test it out. Now it opens. Very cool. Unrelated, but you're going to post that pirate software clip from a couple weeks ago. What you mean? Oh, thank you so much for reminding me of that. Yes, absolutely. And I agree, that is very, very neat. So this is use generative AI to simulate sunrise and sunset. You'd be amazed at how much you can accomplish with the help of generative AI large language models like Unity Muse, ChatGPT, or Claude. These tools are especially helpful for generating relatively simple code. Unity Muse is trained and refined for Unity-specific questions, so it will probably get you the most reliable results, but other LLMs will work very well too. In this expert-level challenge, you'll use one of these tools to generate a script that slowly rotates the directional light, simulating a day-night cycle in your scene. This optional challenge is classified as expert difficulty. So let me sit with y'all for a minute. I'm not gonna go here. I'm not gonna sit here and I'm not gonna, preach as to, like generative AI is like, oh, that's, it's completely awful and you're fucking killing kittens by using it. I'm also not gonna sit here and be like, oh yeah, generative AI is gonna replace every single programmer. Like you need to use it or you're gonna die. Like I'm not gonna do either of those things. What I will say is that it is a very middle of the road answer when it comes to this stuff. AI can be useful if you know what you're doing. It can also actively be a detriment, not just to your project, but also to your learning. If you are handing the researching to someone else, you are not developing researching skills, which means if ChatGPT fails you, you will struggle to find the answer yourself. If you are trying to ask it to generate code and it's generating you code that you've never seen before, you don't know the APIs that are being used, you will not get better in learning how that's used because generally you will prototype some stuff in order to test new APIs out. So you will be skipping that step and you won't be able to understand why that thing was done or how it's done in the way that it's done. And so that way, when ChatGPT fails you, because it's not if, it is when, because as your project grows, code generation gets worse, you will struggle to fix things. You will struggle to add new things, to remove old things. And so if you know what you're doing first, when ChatGPT fails you, you'll have a backup plan to to recover from. You won't be like literally up shit's creek without a paddle. Not literally, but metaphorically or whatever. So that is something that I at least wanted to say is that like AI can be good, but learn what you're trying to do first. Instead of asking ChatGPT, literally just go on Google. Just type in on Google without reading the AI summary, how to simulate a day-night cycle. And then you'll learn how other people did it. You'll learn how the code actually works and why it's being done that way. And then if you want to afterwards ask, ChatGPT to simulate it, maybe ChatGPT could simulate a more efficient one than you've got. But you'll know why it's more efficient. You'll know how it's more efficient, and you'll know how to replace it. The other thing that I will say is that if you're going to use AI, consider using it ethically as you can. A lot of model providers, big model providers like, ChatGPT or like whatever, they may use data centers, as this is especially true in Grok's case. They may use data centers that are causing a lot of environmental harm, in particular to Black communities. And they have no defense against this. They cannot stop it. The only thing that can stop it is money, and not giving your money to these motherfuckers who are causing harm. So try to do some research into the provider that you're wanting to use. Maybe you can use it ethically. You should care. I'm not gonna sit here and preach at you, but if you don't care, maybe you need some therapy and to look into that. That's all I'll say on that. And for what it's worth, you can use local LLMs. That's local AI. This is AI that runs directly on your phone, directly on your computer. What I will say is to go look at Ollama and Hugging Face, and you'll be able to run models locally. And this way you'll know that those models are not running out of a data center that is literally harming Black communities. So there is a way, and if you want to be a decent person, you will try your best to do that, okay? That being said, that's all I want to say on that. So Unity's AI seems gimmicky and might not be great for continued support for your game in a couple years when AI hype dies down. I don't think AI itself is going to die down. I think, like you said, AI hype specifically may die down, but I think that AI will always be a useful tool, if nothing else, because it's a fancy autocomplete. It can do the stupid tasks like far faster than even I can. Like when I built the Meowgicware site, like that probably would have taken me a week to do myself, and then I accomplished it in like 2 days with AI. So I think that AI will remain relevant for programming. However, yeah, it is not some, fucking like God's gift to this earth, or this like one size fits all solution or whatever. So yeah, like you're right in that regard, 100%. So let's move on from the AI stuff. This is to generate a directional, what is this? No, it's a script for rotating the directional light to simulate a day and night cycle. It'll be around, but I'm not sure as a Unity feature will stand the test of time. Probably not. You're probably right. So we did learn how light works, this directional light. What we can do is we can create a new script, and we can call it day night simulator. Come on. We can attach it to directional light. So X is really what we're after. We can say that X is midnight. Or a 0. 0 is midnight. Well, we don't have to get too crazy. AI creeps me out, not gonna lie, which is absolutely fair. That's absolutely fair. So we want to go with X for sure. And then we're gonna be about 90 degrees is like the apex, so that would be, you know, noon. 180 will be midnight because if we go to 0. I guess about 200. And the reason I'm trying to figure out these variables out is because if we go to day-night simulator, we're gonna say start time, public, float, start time, is 0 F, public, float, end time is 200 F. And so for every update, what we're gonna want to do is we are going to want to say this was the X, so it's gonna be transform, rotate, actually, first thing we're gonna do is we're gonna set the rotate to 0 transform dot rotation dot y transform dot rotation dot z. This sets the X angle at 0 or at the start time. And the next thing that we want to do is we want to rotate. However, if the current transform.rotation y is greater than or equal to the end time. That sounds so fucking weird. We're going to rotate to 0, and we're gonna have an actually this is gonna be private public floats time scale equals 1f. 0 plus 1f, or 0 plus time scale, I suppose. 0f, and then yeah, transform. Oh, fuck out of here. No, we want transform.rotation.z. We want to keep whatever the fuck it is. Okay. And then otherwise, we'll do the transform dot rotation dot x plus time scale transform y dot z. Bingo. And yeah, we'll prefix with that. That should work. I think that I will get the I will do some helper methods that are gonna clean this up a little bit. Would get y. Except it's not a void, it's a float. Yeah, that's so much cleaner. Just a little bit, but it helps. Okay. And for this directional light, it is simulated. Let's go ahead and check it out. So it'll probably go really fucking quick. Really interesting to see these change so much though. All right, I think I'll dip here. By the way, I can remind you to upload that clip later today if needs be. Yes, please do. Thank you so very much. I hope you have a fantastic night and sweet dreams. Thank you for dropping by. Oh, I think I get it. Because it applies it. What the fuck is a Euler? Huh. Oops. This is so confusing, but it looks cool. It would be cooler if it works. That's kind of the thing I'm worried about. So if it works, I can explain it a little bit better. Huh. Yeah, that is strange. Well, let's break it down like bit by bit. So if I call this, how do things start? It's to start at 206.87 and 143.57. How does that go? Yeah, the weird thing. Huh. What the fuck is a slurp? Man, fuck math. Do not attempt to edit or modify rotation. Okay. Quaternion Euler angles. What the fuck? Why is rotation so hard? Okay, Euler angles can represent a three-dimensional rotation by performing three separate rotations around individual axes. In Unity, these rotations are performed around the z-axis, the x-axis, and the y-axis in that order. You can set the rotation of a quaternion by setting this property, and you can read the Euler angle values by reading this property. That doesn't make any sense. When using the Euler angles property to set a rotation, it's important to understand that although you are providing the x, y, and z rotation values to describe your rotation, those values are not stored in the rotation. Instead, the x, y, and z values are converted to the quaternion's internal format. When you read the Euler angles property, Unity converts the quaternion's internal representation of the rotation to Euler angles. Because there is more than one way to represent any given rotation using Euler angles, the values you read back out may be quite different from the values you assign. This can cause confusion if you are trying to gradually increment the values to produce animation. See bottom scripting example for more information. To avoid these kinds of problems, a recommended way to work with rotations is to avoid relying on consistent results when reading Euler angles, particularly when attempting to gradually increment a rotation to produce animation. For better ways to achieve this, use the quaternion asterisk operator. The following example demonstrates the rotation of a game object using Euler angles based on the input of the user. The example shows that we never rely on reading the quaternion Euler angles to increment the rotation. Instead, we set it using our vector 3 current Euler angles. All rotational changes happen in the current Euler angles variable, which are then applied to the quaternion, avoiding the problem above. Okay. Yeah, I'm gonna be honest with you, chat. I don't really know what's going on. I can see this works. Yeah, I got really technical all of a sudden. Yeah. Fuck, dude. Yeah, that's interesting. Well, I am curious. Let's go to chatgpt.com. Can you please write me a script to simulate a day-night cycle for Unity's directional light and explain to me how you implement it? Certainly. Why, certainly. Here's a simple script to simulate a day-night cycle using Unity's directional light, which represents the sun. The script will gradually rotate the light to simulate the sun's movement across the sky and allow you to adjust the speed of the cycle. Okay, so we did the day-night cycle. We've attached it. We'll literally just fucking copy-paste this and see what happens. Oh, no, hold on. It's having us do something different. So we have the directional light. Ah, now this is interesting. Let's remove the script. Create a new empty thing, and we'll call it day-night controller. Move it towards the tippy-tip top. Attach the script to that. Drag the directional light on here. This controls the color of the sunlight throughout the day. You can define colors for sunrise, noon, and night. And then the animation curve defines how bright the light is through the day. You might set it to peak at noon, value 1, and drop to 0 at night. At night. Yeah, I mean, fuck it. Let's give it a shot, right? So 0 is midnight, and then 1 is night. So, like... I don't get it. I don't get what that is. So 0.25. It's gonna be orange. Give it a shot at night. And then white/yellow. Orange/red for sunset. Gonna be 75%. All right, let's see how that goes. Light intensity curve. It's gonna be a bell curve. 0. Oh, I don't know what the fuck I'm doing. Want to do. Zero, 0. And then key at 0.25. And 1. 2.5 for a value of 1. 0.75 for a value of 0.8. And then for a time of 1, a value of 0. And just for a fast day sim, and now let's see what happens, you know, like. That's fucking crazy. I'm not gonna lie. Like I said, if you know what you're doing and why you're doing it, AI can be a cool tool. However, I just deprived myself of all of that learning. I deprived myself of mathematics. I deprived myself of learning how a light intensity curve works. I deprived myself of learning how a light color gradient works. I deprived myself of all of that by using that script. So pick your battles, choose what's important to you. At the end of the day, you do want to make stuff, but at the end of the day as well, the more you know, the better you get at making stuff and the more cool your shit will be, okay? But I won't lie, this was hella sick. Some use, not all use is a good way to look at it. Yeah, exactly. But that's cool. So that means we kind of like, yeah, we did that tutorial. Fuck yeah. Will it actually let us take the quiz? Hey, what do you know? Okay, so let's go ahead and complete this quiz. This is your one warning to please, if you want to take it for yourself, pause the video right now. I'll keep talking and give you a second to pause, but yeah, pause it, take it, come back, we can go through it. Otherwise, here we go. Question 1, which of the following are true about scripting in Unity? Select the 3 answers. An external script editor must be used for coding since you can't write directly inside the Unity editor. C# is a default scripting language used for Unity in creating game logic and interactions. True. Scripts attached to game objects can control their behavior, animations, and interactions within the game. Also true. Unity only supports JavaScript for game development and interaction logic. False. Question 2, what is the purpose of the update function, which appears by default in any new script you create in Unity? That is to handle actions that need to occur on a frame-by-frame basis. Question 3, there are 2 errors in the line of code. What are the errors? Well, there's no semicolon. And yeah, the number should have an F to designate that it's a float. Question 4, which statements are true about variables in C# programming? About variables in C# programming specifically. No, but yeah. Okay. So I was like, well, this isn't about C#, this is about Unity, and this is about Unity, but never mind. Okay, so variables in C# can be of any data type, that's true. Variables in C# often use camel case notation. That's also true. And variables cannot be declared. Well, they can. It's okay. Variables must be declared within the start function of a script is false. Some you can if you need them. Otherwise, they should be declared at the top. So that means it's variables can appear in the Unity inspector if they're declared as public within the script. Question 5, you have the code below in a collectible script, but for some reason, when the player game object collides with the collectible doesn't disappear. What could explain this? And there are 2 answers. So the thing that I see, yeah, the player game object does not have a player tag applied. That could also very well be. There is no missing semicolon. The other thing is that the collectible object with the script attached does not have is_trigger enabled in its collider component, because this one is, instead of on trigger enter, it should say on player enter. That's not true. Question 6, what does the instantiate method in a Unity script do? It creates a new game object or a copy of an object at runtime, including all its components and properties. Cool. Yeah, we got them all correct. Great. Hell yeah, chat. So that concludes Programming Essentials. That was kind of exciting. We learned to do some really nifty shit there. And I'm not gonna lie, I do be learning stuff. It shows me that just because I have been decent at programming, whether it's web development, networking programming, or mobile development, I don't know shit when it comes to math and video games. So this is proving to be very, very educational for me. So hopefully it's at least cozy and vibey for y'all, if not the same. But yeah, that's kind of where we're gonna leave it off. I'm gonna go back through on my own and just kind of do the quizzes for the other ones because they weren't working at the time. Hopefully we have more luck going forward. But this is so cool because there are only 2 missions left. We will almost certainly get those done tomorrow. That is hella exciting because then we're done with the essentials and we can move on to the programming essentials or whatever. Or not programming essentials, but it's like junior programmer learning pathway or whatever. So I'm super duper excited for that because we are just kind of mobbing our way through. This will have taken us 3 days and it said estimated 2 weeks for this. So we are getting through this at a breakneck pace. Hopefully that pace continues because I'd love to get to making video games. But I'm also trying not to go too quick because I do want to learn. I do want to do things right because with all the shitty games, and this is not on indie developers, but like legitimately all of the slop that has come out recently across various genres. But like that classic like early access never gets finished, just gets milked for money slop. Like I don't want to do that. I don't want to be that. So I'm gonna try to take things slow, continue like learning, spending my time, training these skills. Clearly I have some mathematics learning to do because I did not understand that quaternion shit at all. I don't understand how the whole rotation thing works. And so, yeah, there's clearly some stuff I have to study on my free time because I'm not gonna sit here and stream me studying math. Nobody wants to see that, but I will probably continue. I'll probably do that on my own time. So I think we're gonna go ahead and call that good. Please. I almost called it as a break. I was about to say, please use this as an opportunity to blah, blah. Thank you all so very, very much. Whether you came and you stayed and chatted, you came and you lurked, you came and you left, you did a little bit of everything, something in between, or a secret thing that nobody knows about, which is a little bit concerning. But I hope you have a fantastic night, morning, day, midday, afternoon, evening, dawn, dusk, twilight, a fantastic breakfast, fantastic lunch, a fantastic dinner, a fantastic brunch, a fantastic 4th meal, or whatever floats your boat. Math is math and always a tad harder than just straightforward stuff unless you're inclined to math things. Very, very true. Thank you all so very much and have a good night. Goodbye.